This is the Agentic Engineering Masterclass, and this is our second session, and we're actually doing it live here in San Francisco. So I have the pleasure and to be live with not only y'all, but the entire folks and the entire team here from Atomic. So introduce yourself a little bit about who you are and a little bit of the background as far as like what we're going to get into, because we're going to get into a whole bunch of things as far as how to use and think about agentic engineering in a little bit different way. Normally when you're used to coding, you're using Claude Code to kind of prompt back and forth, or Codex, or whatever your terminal or agent of choice is. And a lot of times now we're going to have to rethink about how we do this to actually prompt our agents to get the work done instead of actually being hands-on across the entire pipeline. And so if you've ever wanted to learn how to manage agents and have them basically do the work for you and have them self-verify, there's going to be a lot of really technical stuff we're going to get into, but hopefully in the first 5 minutes you can just get into this right away, start working. It doesn't have to be as complicated, and just happy to hand this off to Adam so you can just go ahead and start cooking, man.
Yeah, thanks for inviting me, Ray. Hi everyone, my name is Alex, and I came to the live stream last time to talk about verifiable coding agent runtime called Atomic. And what I wanted to cover in this discussion is how you can start to use Atomic and apply it to real-world engineering tasks. And I also wanted to cover how it might be a paradigm shift with how you use coding agents, and specifically introducing a way of determining when a task is complete and how to think about multi-hour autonomous tasks, multi-day autonomous tasks, and eventually tasks that are running for weeks autonomously. And I thought one of the best way to introduce Atomic is to just give a brief overview of the terminology and what all this stuff means, and then we'll actually do a deep dive and open the coding agent runtime in the terminal and go through real-world examples of the primitives of Atomic and a cool demo with a $10,000 SaaS application from Swix. And so stay tuned for that. So the first term is the runtime, and I talked about this in the last video, or the last live stream, and that's where the environment is where the agents execute. So it owns the sessions, the tools, the model, and the state. And then there's this idea of verifiable and verifiable runtime. And the verifiable component is where you have a claim that's backed by evidence from a coding agent, and it can inspect, and rather than expecting the model to use its capabilities to determine whether a task is done, it uses deterministic gates or other LM as a judge verifiers. And then the verifiable runtime combines these ideas of runtime and verifiable. And then there's these general terms that have been talked about, but without much clarity, in my opinion, which is the idea of a loop, which is you can think of it similar to a for or while loop, and you implement, check, fix, and repeat tasks. And there's this idea of bounding, tracking iterations. And then there's a graph, which just expands this idea into nodes, where each node can be viewed as an agent session, and those can have handoffs as edges, and this whole structure can be a DAG, a directed acyclic graph, and it's a live inspectable record. And then graph engineering combines these ideas into a way that engineers can think about formulating their own graphs, where they can take a process and define a graph that represents that process. And that's where graph engineering and workflow creation are closely related. And Atomic gives you these verifiable primitives that allow you to define graphs, and this engine is the thing that we're going to be talking practically throughout this stream.
This is exciting, man. I'm so glad to have you here, and we have some other folks here in the actual office here in San Francisco. And so this is going to be really, really cool. I'm really excited to get it in here. Because this is a live stream, just wanted to let you know, I will have an edited version. There will be timestamps available down below. So I just want to give a shout out right now to some of the early folks who are currently showing up. ISZOMG, we're live. Also Scented Droid as well as live. Just feel free to drop your comments below. We're going to get to some question and answers in a little bit, but I just wanted to make sure for the folks who are showing up right now, we wanted to get you started as fast as possible. And so this is brought to you by the great folks like you who are showing up. So if you're finding a lot of value, if you found a lot of value in the last stream before, make sure you share this out and get your friend to join in, because we have a lot to cover here, and it's going to be really exciting for all of y'all. I'm just really delighted to get this started. So yeah, without further ado, man, I'm going to let you cook. Yeah.
Awesome. The next thing I wanted to show is let's get set up with everything. So in the last video, I described how to use Herder and Atomic, but I just wanted to reiterate that so you guys can follow along. So the Get Started page, for the Get Started page, I recommend going to docs.bestany.ai, and there's a quick start here that describes how to install Atomic. So it's an npm install. And the other thing I recommend installing is a tool that Ray may have mentioned in his videos. I think he mentioned in the last live stream, which is Herder. And this is a tmux alternative. And what this allows you to do is have a multiplexer so that you can detach from a remote machine and have the work continue. And this is really convenient because you might have seen all those memes where people are trying to keep their laptop lid open and like actually creating products where they try to keep that pride open. So I recommend installing this tool, and it actually fits well with what Atomic does in terms of running multi-hour sessions. With that set up, I'm going to switch over to my installed version of Atomic so we can actually go through a crash course that I prepared. It's pretty dense, but it should cover the very basics and how you use Atomic, and then go into more power user mode and actually building a real project with that, or debugging certain things in your project, and how I approach that and how I create specs. So let me switch over to the terminal now.
Cool. So while he gets that set up, he's getting the terminal stuff set up. Huge shout out to Dion, who is also watching on the stream as well. We got Phil Blanchett in the building. We got Ja Love and FLA. And let's go ahead and see if we can get back into the stream here as we got this whole thing going up. So this is Herder we have live, and this is a really cool UI.
Yeah, Herder has this nice idea of spaces, so you can create new tabs, and inside of the tabs, you'll see that each tab denotes a specific repo that you're on. I only have one repo open here, but in this case, it shows you the main branch, and then you can create new sessions by clicking on this. It's like a new window in tmux, and then there's a menu bar where you can detach from Herder as well, and it allows you to group panes together, and also shows you the status of agents. So let me open Atomic, and we'll get into this deep dive. So I recommend cloning this crash course repo that is pinned as one of the YouTube comments in the live stream, but I'm repasting it here so you have access. If you search for Atomic Crash Course under the same repo for Atomic, then you'll have access to this repo so you can go at your own pace and explore the concepts. If you look in the readme.md file, there's an entire overview of what we're going to be going through, and it has all the prompts so you can reproduce everything offline. So let's start with the very basic usage of Atomic. And Atomic itself has the base primitive of a coding agent, so you can use things like @mentions for files. So if you use this @tag, you can reference files and then be able to pass that directly to the context of the coding agent. And then there's also the ability to execute bash commands as well, or PowerShell if you're on Windows. So I can do something like this, and it will run shell commands. And the nice thing is you can actually then direct those shell commands to the agent if you do double exclamation point. So this will go into the context window of the model. And I can ask, what files do you see in this folder? In this case, it just reran the command, but it would be automatically loaded in the context window. And then you can also just use it like a regular coding agent and just interact with the system. But that's really the tip of the iceberg. That's more boring stuff. And then one of the things that I introduced in the last stream was this idea of hashline editing. So Atomic has an optimized version of the edit tool for coding agents, which allows it to replace text much more effectively. And the way that this works is if I type read greeter.ts and then change only the greeting punctuation, it uses this hashline edit tool, which uses content hashes for editing instead of the traditional replace tool that's used in coding agents. This is more context efficient because in traditional edit tools, the model actually has to regenerate everything that it wants to replace. So it's very error prone. And this is something that I adopted from OhMyPie. And the other feature that I really like about Atomic is it has this cool interactive ask question tool. So if I send a message like scaffold a config file, don't write anything, first ask me a question, there's this interactive interface, and there's also pop-ups that can show on the right-hand side if you want to if you ask the model to create a visual diagram of what are the pros and cons of a particular engineering approach, it can create those, and as you tab around, it'll show you visually what is the difference between certain approaches. So in this case, I'm just going to enter my responses, and this ask user question tool is a great way to gain clarity when working with a coding agent and make sure that you have aligned your intent with what the task is going to do. And I'll show you, this will be incredibly important as we try to scale these systems and the philosophy of Atomic, because I see a future where we have to align the way we approach a problem and spend a lot of time doing that, because if the agents are going to go about solving a problem for multiple hours or multiple days or weeks, you don't want to lose that that much time from a misintent.
Yeah.
Because it can be really expensive to have to go back from a run that was multiple days long.
That's right. That's wild. Cool. This is so cool.
And we have file-based plan to-dos. This is also another typical feature in harnesses, but this actually allows Atomic to maintain context across compaction cycles better. And you can do something like, actually, let me close that. You can say something like plan test coverage for this feature and create one to-do per exported function, then list all to-dos. So what this does, as I was mentioning, is it maintains a file-based memory of what the current task is being worked on, and that allows the model to have an idea of what's important across compaction cycles. This is really important for multi-hour, multi-day tasks where the model needs to maintain continuity.
Ooh.
And you can also observe what it wrote, but these are like internal notes that the model has. And but the other thing I wanted to show is you have this idea of file-based to-dos, and to-dos are a way that you can optimize what's in the session context. So Atomic has this idea of sessions, which are similar to coding agent sessions, but sessions can also be in workflows, which we'll get to later in this guide. But to understand a session, the way I would think about it is there are these fundamental operators like treeing, forking, and cloning sessions. So the idea of treeing is you can switch back towards branches of context. And this is an idea that was introduced by Pi, where you can actually go back in user and assistant messages and be able to select a particular message in the history. So it's like you're reverting at a message level, which is really convenient if the model took a path that was derailed and you're trying to correct its trace. And this is like a low-level memory management technique that you can do, sort of like from an operating system context. You can
just to keep the context clear and so forth.
Yeah.
Yeah. So just can we like recap a little bit of kind of what's been happening so far for the folks who are just joining in? Because there's probably some folks who are just joining in right now trying to figure out, okay, I just got started with Atomic. And so the first things that you kind of need to get started are, download Herder, HERDR. That's going to be basically able to run your coding agent. Preferably if you have like a dedicated machine, it's probably the best way to do this, because if you are running it on your own Mac, as soon as you close it down, your agents will pause or stop and then until
Yes.
you turn it back on. So what Herder will allow you to do if you're connecting via SSH is it'll allow you to keep that session alive. So when you SSH into that computer again, you type in Herder, boom, all of your sessions will load back up and it'll just kind of feel like they're continuing on. So that's how you can continue. So if your connection breaks or anything like that, that's going to be your first level to get connected again. Once you have that set up and you just type in Atomic, it'll load that interface up for you. And then that's kind of where you can start describing any work that you need to get done and so forth. And that'll basically allow you to kind of get started right away with your work. And then how you describe the work is kind of what we were kind of showing you a little bit there with getting this stuff started. And we're going to just dive a little bit deeper. We'll get into some more examples as well. So we're going to take a look at some examples from mine and also maybe take a look at a sample project of like, if we're even creating a new thing from scratch, how does that look like too? And how do we prompt this and what's different from doing that versus like Codex Ultra Mode or Ultra Mode inside of Claude Code as well? Because there are very different approaches here, and this is the best part of this for me. I think is just like the agentic runtime, which is it's self-generating loops, self-generating things to verify, self-generating things that will all automatically kind of keep itself going for a very long period of time, but won't burn through your entire Claude Code subscription in one day, type of thing. So I think that's what's going to be really refreshing, and I'm looking forward to as well. So yeah, because it's a live stream, I appreciate everyone's questions and everyone's comments here has been really, really fun. So yeah, let's kind of just get back into the mix here and just want to get those folks who are just joining in right now and kind of figuring out, hey, what's going on here? And this is kind of where we're at right now.
Yeah, as an update, what we've been working through is the basic coding agent primitives that Atomic offers, and we're just going to gradually build up complexity. But I wanted to show what the reasoning is and how you would go about defining these base primitives like treeing sessions, forking sessions, and thinking of how you manage context in the perspective of operating systems and memory management. So I always like to create analogies between the systems we're building in agentic engineering to systems that we already have in software or other industries, because I think there's a lot of influence there. So I just showed you tree, which is a way to go back in that history. And now I'm going to show fork, which is a way to actually fork the context window and then pass that to a new session. And in the more advanced iterations that we're going to go through, I'm going to show you how to do an even better revision of fork using something called Intercom in Atomic, which is a message passing system. You might have seen that Claude Code recently came up with that, but this has existed in Atomic for a few months now, and also Pi has that feature. It was originally inspired by Pi Intercom. And so there's a fork, which allows you to fork a session and create the context, or take that context from your other session and then pass it on to a new session. And then there's clone, which will literally duplicate the session into a new file with an empty editor. But I typically will use something like fork or tree if I want to correct something, or tree is really good if you want to correct a trace of a model that derailed. And these commands will also work if you use like atomic -- fork outside of the actual atomic CLI. Now I wanted to dive into another core aspect of context engineering, since we talked about these memory management primitives. And on the last stream, I briefly mentioned the compaction strategies that Atomic does. And one of the innovations in Atomic is its ability to work in long context scenarios, so multiple hours, multiple days, or even a week at a time. And something that's key to that is how you are able to compact or manage the context of the model when it reaches its max context window. So most coding agents, when you use something like compact, or auto-compact is this process of automatically compacting when you reach near the context window of a model, most of these systems will generate summaries for what the conversation was and then pass that to the next model. But what Atomic does that's special here is it uses a form of compaction called verbatim compaction. Verbatim compaction, instead of compressing the context window of the model, will actually keep the resolution of the context, but selectively delete messages that aren't relevant anymore. So you can think of, if there's a failing test case in the context window, that's something that you want to verbatim keep, because it turns out if you generate a summary of the test case, the model still has to re-explore the failure, so wastes more context. And there's this idea of, if you have a passing test case, then you don't need to include that in the context window, because that information is irrelevant to the model and just misguides it. So it's actually incredibly important how well you compact. And that's why Atomic is the only coding agent runtime, to my knowledge, that has this verbatim compaction implementation at like a production scale for multiple hours and multiple days.
That is interesting. So a lot of people have also been asking about OhMyPie. And so have you played with that at all?
I have used OhMyPie. OhMyPie is a really cool project.
Yeah.
But the way I would differentiate it is that OhMyPie is more of a coding agent, but Atomic is more of a verifiable coding agent runtime. So you not only can use Atomic as the base of your, not only can use it as a dev tool, but you can actually incorporate it as the runtime layer for any application that you're building. So if you have a web application or you're distributing an application to users, you can actually layer Atomic as part of your agentic stack, where it becomes essentially a part of your backend, or like the modern backend.
Interesting, because somebody mentioned about using Claude Code, and Claude Code was driving Atomic.
Yeah.
And then Atomic would do work and come back and say like, hey, all this stuff is done. And so it's just kind of, because I guess it has all the documentation that's built in, so it can sort of self-run by itself.
Yeah, one of the things that makes Atomic different as well is this workflow engine and the idea of verifiability, where you can take a task and then you can have Atomic create a subroutine that checks whether the task was completed correctly or not. And that can be in the form of creating an end-to-end tmux session or a playwright CLI for automated testing. And then it can also have a LM as a judge or panel of reviewers, and these reviewers can have different personas, like one checks for code quality, or is that clean code according to some definition. One checks is the standards, or like is essentially the style of the code base met.
Yeah.
One checks for performance regressions. There's a lot you can do. Like you can imagine, like you have a panel of human code reviewers and things like that.
I see.
And combining them into like a more powerful verifiable engine. Yeah.
Okay. Yeah, because I have something like that I'm going to try to show on the stream with our existing project. But before we get back into your thing, somebody had a question here. What level of coding skills would someone need to begin a career in agentic engineering? How would you describe that?
I think I would form an opinion of I would study how systems are designed. Like system design is going to be really important in the future, and will continue to be important in the future. How you can think about building production systems, scaling to users. And I really like the way I was mentioning this in the last podcast as well, or the last live stream as well, where having good judgment of like what are good features to ship to customers, and not making sure that you view the process of engineering as more than just shipping features. It's how do you control what gets to users, and how do you measure user satisfaction? I think these are skills that are becoming even more important. And I also think that technical ability will remain important because it gives you an intuition for how to build these things, or like how to design them. But it's more like the way that I analogize it is we went from lower level languages where you need to worry about manual memory management and like in the assembly days, and then in the Fortran days. And now we moved on to like higher level languages like C, C++, Rust, and then JavaScript and Python. And I think the abstraction level changed, but the expertise or ability to deep dive at any moment is incredibly valuable.
Got it.
If you need to figure out how a system works, you just have another tool that allows you to figure out how the system works. So I would say like technical ability and coding ability, like maybe at a fine-grained level is not as crucial, but like curiosity and the ability to do technical deep dives and like figure out how an implementation works is still important. And I would still, to reiterate, I would still learn like the coding fundamentals and data structures because they help you formulate that systems thinking.
I see.
Yeah.
That's such great advice. Thank you so much for kind of explaining that, breaking that down. Cool. That's a great answer.
Yeah, I don't know if you have anything to add to that. Feel free to add.
No, I think you pretty much nailed it. I think it answers a lot of people's questions, like should I drop out of school or something? Like these are pretty critical things that you should learn in systems engineering, and you only get more hands-on experience as I would say just get in the field, start participating in an open source project, make a project with friends and learn together. I think you're going to learn a lot. Just stumbling your way through these things, and I think that's the way I learn. I mean, I dropped out of school, so I learned this stuff on the fly. Trial by fire, yes, yeah.
Yeah, definitely. Open source is a great way to, I think, be able to learn how to work with people and also contributing to projects. You can learn from the other contributors as well. So I think there's a lot of learning opportunities there that you can really create your own curriculum nowadays with all the online resources and being access to coding agents. But as I was mentioning, there's this idea of verbatim compaction, and you can trigger it with /compact, and this is a more effective form of compaction that's available in Atomic that's not available in other coding agents and other runtimes. And then it auto compacts as well, so it triggers compaction at specific thresholds. You can also configure the compaction to happen at certain points. So if you want, you can add like a JSON configuration. You can ask Atomic to modify your compaction settings. This is more advanced usage, but if you want to control exactly when compaction happens, you can do this. A compression ratio here is a key one where it tells Atomic how much to compress using verbatim compaction, where it'll remove more messages if the ratio is higher, and it'll remove less messages if the ratio is lower. And then preserve recent is how many messages are kept from the last n messages. So if you keep recent 2, the last 2 messages can't be deleted. The other cool thing I recommend playing around with in Atomic is the keep context tags. I was mentioning this in the last live stream as well, where you can actually engineer context that's kept in compaction cycles. So if you have something that's mission critical or needs to be maintained, there's a way to do that with Atomic across compaction cycles. So if you use keep context and then you say, make sure to write unit tests for every change, you can actually enclose this into keep context tags. And what Atomic does when it reaches a compaction cycle is it'll look at that tag and deterministically keep it in the context window of the model. And it will only force remove it if the context is overflowing enough to where it can't possibly be kept. And this is a really good trick if you're seeing your coding agents are diverging from the original task or the original requirements that you set. And the nice thing is that Atomic can, the coding agent part of Atomic itself can create these tags. So if you ask it to steer a system, it can decide that this particular information that you gave is really important and enclose it into these keep context tags. And so this is just a regular user message you can send to it with these keep context tags. So that's what makes compaction special in Atomic. And then there's this idea of sessions in Atomic, and we'll see more advanced session usage, but for now, the main session is kind of, you can think of it as like your orchestrator, where you can tell Atomic to run workflows. We'll get into what workflows really are here. And it can steer those workflows for you. Atomic is almost meta in that it can spawn instances of itself, or it can spawn workflows of itself. So you actually don't need to use Claude Code or Codex to steer Atomic. Atomic can steer itself.
Wow.
So you can, if you think about the workflow mechanism in Atomic, Atomic has this workflow tool that allows it to control itself, which means that you could ideally actually do all your agentic work in Atomic's base agent, and then the runtime layer where you have the workflows and the verifiable graphs.
Yeah, so for what it would look like for you when you're typing in the terminal, you'll just have one chat, and the chat looks like it's kind of going on there, but it spawns off things that are kind of running in the background. And they keep working and working, and so you may not even get updates for a little while unless you actually ask and say, hey, what's going on? And then it'll get some of that information back, which I think is really cool and interesting. So yeah, we're gonna dive a little bit deeper for that. Should we show them an example or something? Like I have an example that's currently live.
I have a live one as well, but love to have you share something.
Okay, cool. Yeah, so this is something that we have for what we call like, I call Clippy agent. This is with my friend, tech friend here, who's in the building. So this is actually, you can see this is one PR. And this has been going on for like, I think over 6 hours or something like that. And this is part of like an actual bigger feature change or feature fix. So let me just make sure I have the camera stuff set up here so that's running correctly. So in our thing here, let me just kind of make sure camera 1, camera 2, okay, camera B, okay, camera B, okay, cool. All right, so this is a PR, and let me just show you what it looks like inside of this agent with herder. Okay, so I'm SSH into the box. And so this is what's going on. And these are like little workflows. So you can see that Atomic basically wrote a workflow on how we're going to just go from PR to just closing it out completely end to end. And so in there involves like a lot of verifying bugs and making sure everything's kind of good to go. So I have a Mac Mini in which everything's running on, and it's logged in under my name here. I'm also using Cursor Cloud, so that's how it's basically, instead of creating work trees on my Mac Mini and eating up a bunch of memory, I'm just handing that off to a cloud VM basically, and that's how some of the tasks are being done. And then you can kind of see these little workflows at the bottom. So if we can just go /workflow and then connect, that's going to show us the workflows. And I didn't define any of these. These are literally just made by the actual agent by itself. And you can see some of them have been running for 9 hours, 7 hours, and so forth. And it tells us like what stage it's currently in. And so these were self-defined, and these were just kind of running. As you can kind of see, this is like 98 different workflows. It just kind of goes one to one to one to one. So this will tell us like what happened in that workflow. And to me, like what's actually happening here. Let me just Control X, go back. So there are, there's basically a big bug that we're chasing here. And in terms of like, for my problem, the way that we make clips, it would just spin up and eat up like 1000% CPU. And so what it did is it split up the whole PR into like multiple PRs. And so this is our original pull request. And I just basically said, just fix it until it's done. And along the way, I actually said, can you just split this up into a stack? So that way we can split up the work into these different areas. And that way, when a PR comes in, pull request, it will actually be able to verify its work. So there's 14 different threads of issues that it found as it was going through and discovering these problems. And so these are things that normally I would have to do as an engineer and sit down and like I come back to my screen after it finished, you know, and Cloud Code or Codex would have been sitting there for 4 hours waiting for my own instructions. But it just starts to just write them out, put them back into the pull request, and call them out as additional work to be done. And so the Atomic stuff will then just see this, and it's like, cool. These are great bugs that actually start to actually go verify inside your repo and start to go fix and set up, you know, the whole workflow. And so you can kind of see it basically just communicating all in through the PR. And as part of our pipeline process inside of GitHub, you can set up GitHub Actions to do code review. And so I've created that so that way my agents can kind of start to interact just inside of the PR. I don't need them interacting in some other app or anything. You know, GitHub supports that, so it just starts to do everything all in here. And that way, as a human, I can review it if I want to. So my GitHub Actions will come back with various things from the different code reviews and whether it wants to fix bugs or whatnot. So this is at the point where I started to open other PRs to fix different bugs that it came across. So we can kind of see here, there's another example of a PR that it opened and the type of proposals that it's doing for the split and the type of work that it's not going to do. And it even shows you how it's related to the other PRs that it's working on. So why this is a stack and not on 80, and this is the different bugs that it's fixing. There's already 2 pull requests that got merged. I had not touched this for the last maybe 2 days or so. So this has just been working autonomously for me, and it's just been writing these bugs and actually fixing them. And right now it's even going through because this is red and it's still open. It's still failing my tests for it to even just be merged, and it's not allowed to merge. And it's you know, it's basically doing a full-on sweep. It's all described in here, all inside of GitHub. It's done through PRs, and you can see the agents coming in with GitHub Actions and fixing the bugs and writing new commits. And then Cursor comes in with the bug review, and then Augment app comes in with the bug review as well. And then I have other agents that are reviewing these reviews, and then it does a repair fix, right? So like I had 0 touching Atomic, then launches off Cursor saying, hey, go ahead and start this repair round with all of these things that have been called out and figure out what's going on. And then here's the commit that's going in. So it's nice because you could see, like, while I've been here on this stream, I have not even been taking a look at what's been going on. And you could see even like an hour ago, it's just been doing all these repairs. So item 8, the 3 lines brought into the 1 documentation. And then here's the 3 major repairs that still need to happen. And the fixes and all the different stuff that are coming in. So it's just kind of looping and fixing itself. And this is normally what I have to like spend a lot of time, you know, reviewing by hand and then kind of trying to wrangle all the agents, and they're all just kind of doing their own thing. So, and this is kind of where we're at right here. So I can just say, while this is running, let's say, what is the latest status on what is going on right now? And so we can see this main agent right now is currently running on Opus 5 high. And that's my orchestrator in essence. This is my atomic session, and it's kicked off these various workflows and it's also identified different agents like that are using GPT 5.6, various Sol models from Sol to Terra to Luna to do different tasks, whether it's verifying or doing some other things as well. And that's basically what it writes by itself. So here we are. Yeah.
And I also want to underscore what you just said, where you can switch to different models, and you can use like this idea of Pareto efficiency of cost versus accuracy. So Luna Max, for example, Luna with Max, GPT 5.6 Luna with Max reasoning is a great workhorse model because it's incredibly cheap. It's in DeepSuite, if you measure it, I think it's 12 cents per task. And then if you can combine it with reviewers like Opus 5 and GPT 5.6, you can actually get a lot of high quality work and save in cost as well, because you're delegating to models that are less costly in terms of the Pareto frontier for the performance. And so you can imagine like being able to insert Grok 4.5 and Luna Max and have them as the worker stages, and then have reviewers as more powerful models. And so I think that's another part of Atomic that allows you to do. And I also mentioned this in the last stream, but Atomic is able to select models based on what their strengths are. So if, as Ray is showing right now, you can list the configured models and have Atomic decide based off of DeepSuite or artificial analysis what a model is good at. And this is the idea where the runtime really comes in. You could be working on maybe a app for legal applications, and you can ask Atomic what model is good for that, and it has access to that information. It could tell you based off of this artificial analysis benchmark, or which model is best for writing. Yeah. So it's really able to select a model for a task based off of the efficiency and the performance.
Exactly. And in my case, I just wanted to design it so that it would run in the cursor's VM. And in my mind, I already had, for the implementer, Opus 5, and I wanted Fable 5 for an architecture review. So I just told it to use that. And then correctness review, 5.6 Sol. And for integration, I just wanted a quick Grok 4.5 pass on it. And so this is really cool. And this is kind of what it's doing. And you could just say, can you look up the latest and see if it's the right thing still for my project? A big part of it for me is that I wanted to run everything as much as I possibly could in the cloud. And there are ways to do that. And you can talk to the Atomic runtime, and it will configure that for you. So there's a popular one called Crabbox from Pete Steinberger. And he made this so that you can launch tons of cloud VMs and do these things as well. So you don't have to use Cursor. Because I'm already a Cursor subscriber, that's kind of why I'm taking advantage of their cloud compute. But you can do that on Crabbox. You can do that on your own infrastructure that if you have custom set up, your own Mac Minis or whatever you got, your own compute and stuff, you can spin that up. You could even use these other providers as well. So I think that's kind of like a quick example of what's going on. And it's kind of nice how it just kind of loops back for itself, and I don't really have to do much in terms of these things. And this is like another project that I have running, and it's literally just doing security checks and code inspections, and it's just, I'm just telling it to do, like it even told me like this, I had to like generate an actual page for myself, because I couldn't actually read everything in a markdown file to keep track of what's going on. Yeah. So I just said, can you just create an HTML file that just kind of gives me an overview of like all the stuff that you did?
Nice.
And this is all that it did. So like it did a full on like all of this work. Like I didn't have to touch any of this or even hand off multiple chats. The runtime took care of all this stuff for me. And so it did these like, this is exactly the sequence that the workflow did, right? Quota billing, there's a massive refactor that I did that I haven't merged to main yet, but I just wanted to make sure I didn't miss anything. And you can see all the models that it used in here. GPT 5.6 Sol High, Fable 5, Grok, Opus, Sol, for all of these different parts, whether it's security, whether it's web uploads and so forth. And these are all the merges that happened. And then this is like all, the whole things that it did there. So like I can just go back to the whole session report. And then these were the different bugs and stuff that it called out. So it's kind of nice when you tell the agent to just make an HTML file, and out of those review, it found all of these bugs and it fixed all of them for me, because I just told it, just fix all of them. Launch multiple sessions. So this took probably about like 3 to 4 days of it going. And I would just pop in and check these different things. But this, like, to me, is how you become like kind of unstoppable at this point, because there's no way that I would just be up tracking all this. And the slowest part of this whole equation was literally just me, because I would have to be the one to have to make sure I popped in, remembered what was going off, hand it off, and then I would just have too many to-dos on my back end, and then I would just never get stuff done. So if you're starting from somewhere, I think the any goal is to try to see if you can you hand stuff off to any systems and have them review themselves and have them self-fix themselves and self-verify, is like probably one of the biggest unlocks that we can finally start doing today, where today Claude Code, Codex can do that if you spend a lot of time configuring things. But the bigger part of it is like once the models change, or trying to use multiple models at the same time, that's kind of where things start to explode, because people are already seeing that between GPT 5.5 and 5.6. Like the literally like the agents MD files don't behave the same way. Claude as well, the Claude MD files just don't behave the same way. Skills files don't behave the same way as well. So people are seeing so much variance just in one major model release. And that's why the Agentic runtime defining workflows are really important, because that's literally just in code, and that will just like follow procedures, right? You're not waiting, like the way that the model is trained can behave very differently, but once it launches into a workflow, that's very deterministic, and then that's kind of the bigger gain here. And so we're just going to kind of keep going here, and kind of I'm going to let him kind of continue here. But I thought if you're just trying to figure out what does this all mean, why should I be paying attention, why should I start using this, that's probably the bigger reason why, is because no matter the model releases, no matter the infrastructure, you're bringing in your own Claude Code sub, you could bring in your own ChatGPT sub, you can bring in your other subscriptions from Grok and these other places, because it's literally just Pi underneath the hood for how it runs the other parts. This runtime is just really, really cool. And I highly suggest you check it out, because it's just super fire as far as like the powers that we're just starting to sort of unlock with some of these guys. So yeah, let me just go ahead and close some of these things out here and then get back to you here. Yeah.
Awesome. And also to add on to your point, for the logins, you can use the /login command, and you can use subscriptions like your Anthropic Claude Code subscription hasn't been blocked for now. We'll see what happens in the future. But there's also GitHub Copilot, Kimi, OpenAI Codex. You can use OpenRouter, Radius, XAI. And then there's also API key support. So you can directly use API keys with Atomic. But I think actually the biggest unlock for most people working on personal projects is using the Codex subscription or the Claude Code subscription, because you get a lot of subsidized usage and can actually start to explore more with these tools. I think XAI also provides XAI and Cursor, but I think Codex and Claude Code offer the greatest subsidization, especially Codex. Codex has a lot of subsidization. So you can spend thousands or tens of thousands in actually a $200 per month subscription.
Yeah.
Yes, so I was talking about sessions, and Atomic has this idea of sessions. But what makes Atomic different is that you have this main chat session, and then you have workflow sessions. So typically, you'd have one session that you're working with, and you're spawning sub-agents. And the term that people use for spawning a sub-agent with a depth of 1 might be like a recursive language model, or RLM with a depth of 1. But Atomic takes this further, and as Ray was showing, it has these ideas of workflows where you can spawn parallel, what I call state machines or recursive state machines. Stay tuned for more information on what exactly that means as a initial kind of taste of what Atomic can do. But each state or stage has its own context window and can delegate and pass context between those stages. And this session management idea is something that I'm going to go back to, but I just wanted to kind of introduce this idea. So you can, in the main chat, you can export sessions. And what this allows you to do is, like you have in typical coding agents, create an HTML file or a JSON-L file to represent the session. And one of the superpowers of Atomic is its ability to actually analyze sessions. So you can ask it, what happened, what was I working on for the atomic repo in, let's see. And what this does is Atomic can actually go and look at its particular its session history, and then be able to identify things that you had worked on, and then you can actually reference that for a new project where you can see the things that Atomic had worked on. This is nice, especially if you have work that feeds onto other work, and it allows you to have this kind of working memory primitive that you can plug in. So this is where the sessions are really cool. So in this case, it's talking about, oh, you were using this stack layer workflow, and this is like the topology of the workflow. And basically what we can do is you can pass this memory to solving other problems. And you can say, oh, how did I solve this problem with the workflow before? Can we replicate that same process here? So,
Wow.
So that's where like the sessions are really powerful. And I'll show you like how you can handle nested sessions as well, and the power of workflows. But this is kind of a sneak peek of that functionality. And then the other thing I wanted to cover is that a lot of people don't cover is this idea of extensions, where you can create extensions inspired by Pi, and you can also nest them in workflows. So an extension is you can think of it, it's like a package that allows you to achieve certain functionality. So you can define custom tools, you can create hooks if you're familiar with hooks. Hooks are like doing operations based off of a particular event from a model. So every time a model outputs a thinking block, you can do something, or every time the model outputs a tool call, you can deterministically do something. So this allows you to control kind of the lower level primitives inside of the workflow itself, which is why I thought it would be important to describe here. So if I tell Atomic to create an extension, this extension, I also covered a similar extension in the last live stream, where you can create this greet tool, and then you can register this command, a hello command. And what this does is when you reload the session with /reload, it will actually reload that, and then I can say /hello, and then I can say hello streamers, and it will output hello streamers. So it's like executable code that you can actually run in the Atomic runtime. And what this allows you to do is it gives you the lower level primitives within a workflow. I'll show you how like that can be incredibly powerful, because what you can do is you can define a particular task or a domain specific tool in a process and have Atomic's workflows inherit that. And this can be also custom UI that you want to represent. So one part that Atomic is really good at is creating UI to represent an output from a coding agent. So you can have like maybe a dynamic dashboard that you can visualize in the TUI. That's a much more advanced usage, but it's TypeScript, so you can execute arbitrary code that you define for extensions, and then be able to also nest them in workflows.
Yes, this comment is actually very appropriate. It's like, yeah, you can go super crazy. It's absolutely crazy. Yeah.
I'm going to show you a practical example of an extension.
Cool.
So one problem with these systems is they can execute any command, and there's the idea of sandboxing, and then there's also the idea of using extensions to prevent certain commands from being run. So in this example, what I'm doing is I'm defining an extension that on tool calls checks if there's an event that includes like a dangerous command like rm-rf. You can be even more sophisticated. Like what you could have a classifier model like the auto mode in Claude Code. So you could engineer that, and you have a model that determines. So you can define an extension, and then even more complicated, a workflow that will check whether this command is dangerous from a SLM, a small language model, and then that will block certain commands. So it can return this block true and reason blocked by user. Oh. So if I actually reload this, and I ask the model to run this rm-rf command.
Bro, I don't know, man. Are you sure, bro? You're gonna risk it for the biscuit? Let's go.
As long as he's not in the home directory.
Not in the home directory. Okay, GG guys, stream over. Yeah. Well, yeah, we're RMRF.
So look, it prompted me, it's dangerous, would you like to allow it? And so I can say no, and I can decline that. And it returns
Nice.
blocked by user, so nothing was deleted.
Epic. Yeah, you can have it send you a text or a phone call. Hi, your agent was trying to RMRF this crazy ass directory.
But this is a very basic example. What I was mentioning is you can
Oh.
use a small language model
Uh-huh.
and prompt it like your local DeepSeek instance.
Yeah.
And since you're hosting it in your own Tailscale net,
Yeah.
there reduces the risk of someone prompt injecting your active instance. And then
Wow.
you can have the DeepSeek model auditing the command for whether it's a dangerous command. And this could be an extension or a workflow. I'll show you how to like plug that into a workflow. Extensions are much less powerful than workflows, but extensions can be nested inside of workflows. That's how they become incredibly powerful.
That's crazy.
But I want to show everyone what extensions are, so when we go to workflows, it isn't completely overwhelming. I want to build up that knowledge incrementally. So extensions are something that Pi has, but Atomic significantly expands that into workflows, and workflows are like an expansion of RLMs themselves. So it's so I've heard some talk about Prime Intellect and their harness for RLMs, but Atomic's harness is an innovation on RLMs. So it outperforms RLMs. It's something called recursive state machines. So it's models defining nested graphs or state machines. So it's I would consider like this idea of how do you improve RLMs as an open research question, and this is Atomic's take. But stay tuned on, there'll be a blog post coming and a vague post coming as well.
Well, this is the vague post, right? Shots fired already. Prime Intellect, we're after you, right?
But Prime Intellect is a very cool example
Yeah.
of kind of what you can do with harness innovations.
Yeah.
And so I think, yeah, they're also a fork of Pi, and it's a cool concept like overall RLMs. But Atomic is like taking a step further, like what is not there that we can introduce. Like RLMs have already been out there for a few months now, from the paper from Omar and his lab at MIT.
Wow.
And I wanted to think about what is the future of harnesses and what is a better way to design these systems.
I see.
So that's Atomic's architecture. Also, it's open source, so you can actually probe how everything exactly works.
Wow.
The part I forgot to mention is you can ask Atomic how certain things work. Like I could ask, like, how does your compaction algorithm work? And what Atomic has access to its own documentation, so it can, unlike the other experience that you might have seen in other coding agents, it has very in-depth information, so it can give you precise technical insights about how the harness was designed. And so you can treat Atomic as a way to better understand agentic engineering, context engineering, graph engineering, loop engineering, all of these. So,
because it has a concepts about them. So somebody mentioned this, and I thought it was a really interesting comment, is that my fear with Prime is the same with Hermes, is the fact that like, since the agent decides what it learns, it might learn the wrong things about my project, and I like this implementation better. What do you think? Is that correct, or is that just kind of like?
So my, could you repeat the question?
So they're saying that their fear with like the Prime or Hermes is that the agent decides what it might learn, and it might learn the wrong things about their project, as opposed to what you're doing here with Atomic. Is that true, or is like what's kind of maybe double clicking on that, going a little further?
Yeah, that's an interesting question. I would say there are still open problems to be solved, like aligning with the intent of the user. But what Atomic does, it gives you the primitives to be able to align on the requirements of your system. So if you're saying that this is a particular task you want to solve, this is the mindset shift that I think we should have. Is you should be thinking about how can I be as specific as possible with a task I want to achieve, and what are criteria that determines whether that task has been completed. And I think a lot of people have started using these newer harnesses like RLMs, RLM-based harnesses, or recursive state machines as it exists in Atomic, and thinking that you can treat it just like another coding agent. But it's more than that. It's like the entire runtime. It's the entire layer. So the way I would describe it is like, how can you define that process that achieves that result? Don't think about just prompting locally. Think about what is the task that you want to do. Like, how would you as an engineer approach solving that problem? Let's take an example, right?
Right, yeah.
Because I think that solidifies it.
Yeah.
The way that someone reviews code is I view as a specialized thing. Like, if you have a particular engineer, they will look for certain things. Like, they'll define certain criteria. They'll say, is there performance regression here? Is the code quality good based off of the standards that are existing in the code base? That key part is based on the standards existing on the code base, because you're using the code base as understanding of what is relevant or what is important to the engineer. So you're distilling on that code base. And the other thing could be, for example, has this been thoroughly tested? Do you have evidence or do you have artifacts that are generated that show you that that change was reliably implemented? So there are a lot of these subsystems that come together, and once you combine these ideas or you become better at describing what you want, I think it improves the performance you get. So the more specific you are, the better. And I'll show you an example of how you can be more specific with Atomic, and that's unique to Atomic. So Atomic has this prompt engineer skill. We are actually covering it last stream as well. But I was talking about how, so you can invoke skills with slash the skill name, or you can do skill and then slash prompt engineer. You can also invoke them in natural language. So you can say use the prompt engineer skill. So I'll do natural language invocation. Use the prompt engineer skill to improve this prompt. Fix my test cases, please. And then I'll just quote that.
Cool.
So this is, I think, what takes someone from working in a 5,000 to 10,000 line code base ineffectively to scaling to multi-million line code bases. Like, if you want to ship to production, the most important thing is having this idea of what is the process and how do you achieve the goal of that process. And so this prompt, like, you're working on this project with this test framework. Make the failing tests in this pattern pass, and then it's how do you repro that issue? Like, you're talking to a real engineer. What are your constraints? What can you not do? Like, if I'm testing a CLI, do I have access to authenticated credentials so that I can actually interactively test something and provide you evidence?
Makes sense.
What is the success criteria? It's exactly like creating tickets for another engineer to work on.
Wow.
And so Atomic gives you this for free, basically, because it has this prompt engineer skill, and you can use it to define what your workflow will do. We haven't even gotten to how you can use that to define what the workflow can do, but I wanted to give a taste of how you should be incredibly specific and kind of driven with this process.
That's cool, man. That's wild.
So that's a very important point, I think.
Yeah,
Like,
I think
the
people are
mindset
still
shift.
shocked on the multi-million part. Yes, he said multi-million. Yes, gigacode, exactly. Yeah.
Yeah, what Atomic is optimized for is how can we scale to production-style code bases that are millions of lines and tens of millions of lines.
Dang.
And eventually, hopefully, one day we'll reach like the Windows-style size code base, like billion or like a billion plus.
That's crazy. So I think the problem right now, and people are seeing it, is that, okay, I started off with agentic coding. I had to create my agentsmd, and then the engineers thought, okay, with agentsmd and cloudmd files, let's make it so that we can nest them so that they'll live in specific directories. So maybe a year ago, that was kind of the trend, was like, let's, make sure your agentsmd files are very specific. So when a coding agent enters a specific folder, it'll have some idea of where to go. And let's just have an index somewhere so that it can kind of reference out like an encyclopedia, because it doesn't have to keep everything in memory. And then in comes skills, right? Skills have been introduced into the game. It's like, cool, let's just define our workflows inside of these skills files, step-by-step procedures and so forth. But as you may come to figure out, especially if you're using language models, they're still deterministic. So they won't always follow the workflow. They may just decide, step 3, I didn't need to do that. You know, like I'm Opus. I know better than you. Like this is already chill.
Yeah.
So by the way, I'm already close to the end of my context window. I'm just gonna get out of here because I think you just have what you need. You'll figure it out. And it's like, well, like it was in my scale file. I was supposed to follow it. How come it's not so procedural based? So this is the next evolution, is basically runtimes. And that's what Atomic is providing, is just how do you have a system that can kind of sort of guide itself in the environment that it's in, and then start behaving in a way that like you don't have to front load everything. And so that's, you know, this agentic runtime. So you don't have to give it everything and bloat the context window. It's going to self-manage those things. And so what you need to do is you need to give it these like primitives or these little tools and stuff that will allow them to sort of extend themselves or send themselves off on these different missions, right? So imagine you wouldn't send yourself into space right now. You would probably send a robot into space, and the robot will explore and give you information and send that stuff back to you. So then you can make a better decision on where you should actually head off to, maybe that planet over there instead of this planet over here. So, and a large code base is kind of the same thing. There's a lot of stuff that's going on. You don't want to put the agent in harm's way. So you want to send it off and to do, you know, and when you send off those agents, that spaceship that you loaded up with, you want to make sure you give it the right tooling and the right things that it can do so it can operate by itself, right?
Yeah.
And so this is like a runtime. It's like, can you give it everything it possibly needs, or can it build itself so that it can start to run itself and figure out its way around to get the stuff done without, you know, killing your context window, eating up all your tokens, and being actually able to feel like it's another team member. And this is kind of why, like, this is such a breakthrough moment right now, and people are sort of seeing this already that are posting online at these big labs, like, you know, graphs, loops and stuff. But we're trying to get into it with more detail. It's such a thick topic to take in. It's going to take multiple days, and I'm just really glad that you're showing up. If you're watching this is part of a live stream. I will have the entire transcript uploaded into the YouTube video. I'm also going to work on getting the transcripts uploaded to my website as well, rayfernando.ai. Because I'm just realizing that people are taking the transcripts and they're throwing them into Claude Code and all these other places to get in some information. I'll also have chapter markers here as well. And we'll probably have more sessions like this too live. So this is going to be something that we want to do. We're currently live in San Francisco. If this is some type of meetup thing that you guys want to do more often, let me know, because like this is literally the room with us right now. We're currently here live with everyone, hanging out. AJ, we got some other folks over here. Hanging out, and we're here in sunny San Francisco, kind of enjoying ourselves, you know, kind of making this happen for y'all, because this is, to me, like, I don't know, it feels like the next movement in the AI space, because it's going to unlock a bigger capability, and it's still a lot for me to take in, and so I'm just kind of happy to have you here. And excited to see the next steps. And so let me just answer some quick questions real quick from the live stream and see what people are saying. And I feel like everyone's kind of, you know, super excited about this technology, and excited that you guys are here as well, because this has just been really cool. It's really funny because it says Opus goes off on its own all the time. Soul stays better on track for me, of course. Yeah. It says, you always share the exact thing I need exactly at the right time. Hi, Alex. Greetings from Barcelona. It's too late in a day to be so. Okay, cool. Yeah, Atomic is crazy fire. I know people have been using it so far to like ship software and stuff like that. Yeah, cool. So yeah, it's kind of fun that you guys can catch us live right now. If you're catching this live, just share it right now with a friend, because we still got some time. We want to go through some more workflows. I want to see if we can get a challenge going across too. There is this project from Swix. If you're not familiar with Swix, he runs the AI engineering event. A legend in the AI space in general. He also has a podcast that he runs as well, where he interviews, like, he's been doing this for such a long time, and huge respect to Swix. And one of the cool challenges he has today, which is blowing my mind right now, and a lot of people are participating, is this says $10,000 to kill my SaaS in a weekend competition is currently live. So you can use any coding agent, any model, up to $500 in token spend, including subscriptions, if you are able to get in. And so what they're doing is that he has this SaaS that I think he's paying $40,000 a year for enterprise SaaS. This is exactly what he's doing, you know, for all these different things. And what it does is it helps him basically, you know, take submissions and all this stuff for his whole event. And what's amazing is he has a whole Google Doc that spells out exactly what he specifically needs. And it actually, he doesn't need the full application that he's paying for. He just needs some features of it. And there's so many people that are participating that it's just beyond the wait list. And I thought, hey, this would be a fun idea to maybe see if we can throw Atomic at this and maybe ask you some questions as well for how we should take something like this where somebody actually has requirements. They're pretty well spelled out as far as all the things that he needs and he doesn't need, including screenshots. And how do you hand stuff off like that, maybe for like a greenfield project or something? So stay tuned. We're going to probably see if we can do that, but also get into, before we get into that, maybe get into some what that looks like for just how do we launch Atomic in our own code base, fix some bugs, do some things like that. You saw an example with me, how it's just running for multiple days off, creating PRs on itself and still going while we're speaking, like probably merging itself to main. I have no clue what's going on, but yeah, we'll see what's going on. So yeah, let me just get back to what you guys are doing here and so get your screen share here. So, yeah.
Yeah, I wanted to underscore one of your points about how a lot of people are working with skills. And what I've seen is so we talked about this as well in the last live stream, but people went from prompts to skills. And now I see them going into these ideas of workflows. And I want to just describe where we were with skills. I noticed that many people had started doing the process of first first run the npm run dev command, then start playwright CLI and take screenshots of the current UI state. And then third, we could say incorporate add a screenshot to the PR of evidence that the UI bug was fixed. And if you think about this structure, you're really just encoding a workflow. And so the idea is why not just transform this process that you have defined and give it the right primitives to have a workflow and it automatically creating these artifacts and not relying on the model having to execute complex. Sometimes even I've seen people with 20 or 30 bullet points describing exactly what they want. And there's no way to have assurance. You have to read through the entire trace. Another thing that makes Atomic special is you get access to stages that have certain restricted information. Like this stage is working on running the application and making sure that it starts up properly. That second stage is then spawning the actual UI session or with playwright CLI and clicking through and identifying any UI bugs. So these ideas, I think, naturally lend to what workflows are. So as a great way to get started, I would recommend trying to convert your skills to workflows. Just start by prompting Atomic, how can I convert and then insert the skill name, right?
Oh.
To a workflow. This is like a great prompt pattern. Like, how can I convert this to a workflow?
Whoa.
And especially if you're trying to tune your skills already, I think a challenge I have for you guys is, can you tune a workflow that achieves the task that you want to do?
Wow.
And think about maybe converting skills to workflows, because you're already inherently doing it by kind of giving instructions or defining criteria.
Wait, hold up. Can we do that live right now? Because I have one or two or three.
Oh, do you want to do it on yours then?
Yeah, I'll do it on mine.
Okay,
Yeah. Because there's one from, I think, Lauren from Cursor. She goes by the name Potato, and she called hers P-Stack. And she's like legendary because she does like hundreds of PRs a day. It's insane that her speed is just crazy fast. But in their skills file, they're so rich with so much information. And one of them is like removing unnecessary comments. If you're a Fable user, you'll see this. You'll get like massive comments coming in for all of your PRs that just say like, 3 lines. It just describes what the function does. It's like, okay, the code it's very readable. And what's really weird is, especially when language models are trying to read your code, is that the comments get in the way because it starts to distort the meaning of what the function does in some ways. And because some language models they grep in a certain way, they may update lines of code and they may not update the comments as well. So you may have stale comments with code that's completely different. So she has a skill that just removes the unnecessary comments.
Oh, that's a great example where a workflow would be really useful.
Yes. Yeah, it's just a workflow. It just happens every time. So the advantage here, instead of having a deterministic on whether the skill runs or doesn't run, as a human, you either have to invoke it or set up a script to invoke it. So the workflow can just say, hey, I'm self-defined, so after every run, I'm just running this as part of a cleanup task or something.
You could do that. Yeah, you could. Well, this is more advanced usage, but you can nest workflows inside of each other. This is where the recursive state machine idea comes in. So if you run a implementation with a worker agent, or worker, I guess like a Ralph workflow or a goal workflow, you can have another sub workflow that does the documentation changes and syncs the code with the documentation, and it deterministically triggers. So you don't have to say implement this and then say invoke this skill. You can just have that process running for multiple hours, and you come back and the PR is submitted and has the documentation updates that you wanted. You're defining this procedure for your specific code base, so it becomes incredibly powerful when you can build a domain-specific workflow. But the primitives that Atomic provides also has built-in workflows, since kind of building a custom workflow can be daunting initially. So Atomic allows you to think about how do I start with workflows, and then how can I become a power user and define my own processes.
Yeah, let's kind of dive in, because I want to, let's delve, folks, let's delve.
One more thing I wanted to say is skills and workflows are also complementary. So if you have a skill that's defined that does a process, you can invoke that inside of workflows, because workflows at the end of the day are stages or sessions that are abstracted. And a few of the workflows that I'd recommend looking into for Atomic, or skills that I recommend, are the create spec skill, which has like a strong framework for defining specs for coding agents to follow, and it has like this intent framework where it will try to identify and build a common understanding between the agent and the engineer. And there's also another one. So we'll show the create spec in this building the SaaS challenge and how I would use it. And then
cool.
There's also tmux, which spawns tmux, and also on Windows spawns psmux, so it's cross-platform compatible. And runs a CLI testing kind of harness that allows you to be able to check the correctness of your CLI applications. And then there's Playwright CLI, spawns the browser to check the correctness of a change, like a UI change. And then another cool one, there's like a skill creator one, which will create skills. There's a research code base one. Light parse is really cool because it does PDF and document parsing for you. So if you give it a PRD that's a PDF, or any online, like if you give it like a research paper, it can parse that natively and extract images. And then there's subagent, and then there's Intercom, which this will be really exciting when we get to this. We're almost getting there.
I want to see if you can do the thing that came about from Swix, that challenge. Maybe we kick that off. What do you think?
Oh, okay, yeah, we could.
Like, how would you approach it?
It might be initially overwhelming to users how I would approach it.
Okay, got it.
And that's why I wanted to kind of go through. We're almost there.
Okay, cool.
But it's like you still have to go through like how do you use workflows, how do you connect to workflows, how do you manage workflows.
Got it.
And then we'll get into
let's just go into workflows then.
Yeah. Sounds good. Do you want to try to convert that skill to a workflow? Would that be?
Sure, that could be fun, because I think that could be really useful for folks who are watching, like who have skills and stuff and are trying to figure out, okay, how do I get like something to a workflow or something like that? I think that'd be really cool. So I'll just look up a pstack, potato, cursor. Okay, cool. So I think this was cursor pstack. So this is the pstack that has, hi, I'm potato. Potato. I'm not a president or CEO, but I worked with millions of lines of code at Meta, Netflix, and Cursor, and I'm also a React core team where I help build and maintain the React compiler. There's a growing sense that AI writes too much code slop. I agree. I don't want to ship like a team of 20 slop artists. I just love everything about Lauren. It's all awesome. So pstack is my answer. Pstack gives you fearless parallelism. Cursor gives you the best of both worlds, right? So add plugin pstack is kind of how you get this set up. So in this here, there's a couple of one, potato agent and comment sicko subagent. So I think this is the comment one. Pstack ships comment sicko. It's a comment reviewer, and so this is like cursor specific, but this is probably where we can have our agent take a look and see if it can actually go through it. I'm just going to describe it in natural English.
Yeah, honestly, what you can do is give the repo URL and ask Atomic to convert it to an equivalent workflow.
Yes. Let's go to...
You can even specify what models you want to use for certain things.
Cool.
Or you can have Atomic to use its best judgment, like based off of its understanding of what models are good at. Like, it's really flexible.
Awesome.
Yeah,
So
you can probably run this one locally if you want.
Yeah. Just gonna run it here. Cool. So I have currently set up in /model Cloud Opus 5 High. And then I'm just gonna say, whoops. Let's see, can I get the copy, paste? Okay, cool. Whoops. I'd like to see if I can convert the workflow about, wait, hold on. In this repo, there is a really great skill in there about removing unnecessary comments and helping me remove AI slop. I'm wondering if we can review it and then help turn that skill into a workflow for this repo. And we'll just go. So here we are. I'll fetch the repo and see what's there. Fetching content, fetch. Cool. This thing's really fast. Wow.
Stay tuned for a new version that is coming in the next few days, which is even faster and more performant.
No way,
because
dude.
of,
This is crazy. It's nice and fast. Let's see here. All right, so here we go. It's cooking. So now it's reading your stuff right here. Cool. So this will basically read the files, read your own things. It's like, I'm seeing there are over 8,000 comment lines in this repo. With Rust being the dominant language, right? And so it's already inspected my own repo and just looked for those comments. That's pretty fast. The verification gates are strong that we have. So I've read both skills. Here's my read before I build anything. What's actually good at? The core insight is adversarial. The agent wrote the comment defends it, so the fresh context header with no authorship has bias. The keep list and the short closed, and the best part isn't deletion, it's must kill. A comment explaining a surprise in our own code is a design spell. So it flags the symbol for rename extract type instead of just erasing the prose. That's awesome.
So that's asking you questions about how do you want to design the workflow.
Ah.
So it's saying, what should the workflow hunt? Code comments only? Or,
yes. What do you think?
Yeah, let's do code comments. Yeah, we can go with the suggestion.
Okay, code comments.
And then, yeah, what should
default scope be when you invoke it with no arguments? Should I invoke it or should I just run it every time?
It's your choice, yeah. I think you can include arguments if you want.
Okay.
Maybe let's go with the suggestion.
Okay, yeah, just like so that it doesn't kill my whole repo. Okay. And then how far should it go without you?
So this is the thing where you can control like the persistence of these models. I think a lot of people have talked about these models will overdo the task. So this is another benefit of workflows where you can have these gates to control the task, the kind of how far these models will go without you.
I wanted to just go all in. How should it treat the repo's load-bearing operational comments? Let's see. Extended keep list with the repo. Add an explicit exception class for irreversible internal constraints outbox. What does this mean? How should I treat this repo's load-bearing operational comments? There's comments in there that are load-bearing? Why would they be so load-bearing? Can't they just be in code? Any comment citing a Docker agent survives? Why would there be?
Yeah, so you can have this back and forth so if there's something that's unclear, you can chat about this or add a specific answer that asks like, can you provide more clarity on what you mean here?
Okay, submit answers.
And this is the beauty of having an ask question tool because you can have the user apply it to multiple context in the CLI.
Fair challenge. Let me check instead of assuming. The workflow only touches code comments, and the operational knowledge I cited lives in agentsmd, which it never opens. I see.
And this is where judgment comes in.
Yeah.
You as the engineer are defining this
Right.
this graph, and it's important that you are able to inject your own judgment and take that process that you have materialized in your head and actually make it practical for the coding agent to apply. So you're like distilling your knowledge into the runtime layer.
So what I'm basically saying, well, since the models are very smart these days and we're using Atomic for the workflow, I think will want to thin out our agentsmd and cloudmd files so that they don't take up a lot of context. And I think that's another paradigm here too, is that for a while, I have these giant, agentsmd files, cloudmd files. Even though I thin them out, they still get more cruft over time. So I'm just kind of telling it about that. And,
yeah, I would honestly recommend removing your agents.md or cloud.md files and encoding those criteria directly in workflows. They can complement them, but I think the beauty of workflows is that you can locally scope your kind of agents.md and cloud.md feedback. And I think a lot of people have been noticing that you don't need as many details in agents.md and cloud.md, and it can hold back what the model is capable of. And I find the nice midpoint of this discussion is just encode those processes in the workflows themselves.
Wow.
Because you probably in your agents.md or cloud.md have, well, at least for me, do this a certain way.
Yes.
Or like check that it does it this way. But you can really define that in the workflow that you designed, and we can get into that.
Wow. The 3 nested files. The models are smart now is the wrong access. None of that 3,600 is teaching the model Rust or React. It's local facts. It's like getting angry at me. I was like, yo, chill, bro, chill. Yo. Yeah. That's funny. It's like was trying to write something. It says ask user question verification fail.
Oh, this is just because the choices it gave you were over 60 characters. That's just so with the UI widgets, you can control how much text they output.
I see.
And to reduce reading through a wall of text, I decided to make the tool have shorter summaries, essentially.
That's a good idea.
And there's a open issue for Atomic which adds a mode called I have ADHD, which will show you much shorter descriptions of what
That's amazing.
That's an open issue if anyone wants to take it.
Wow.
So you don't have to read through a wall of text, because I found that really annoying.
Well, Fable loves to be really verbose.
Yeah.
Like, it's crazy. I'm like, wait, hold on, what am I reading? Wait, it's just...
I'm thinking in terms of the next thing.
Yeah.
I want to describe how subagents and intercom work, and then those are the right primitives to then get into workflows properly.
While this is going, maybe we can do that here.
Okay, that sounds good. Yeah.
Okay, cool.
I figured since there's a general experience in coding agents, I want to dive more into specifically more of the Atomic primitives and how it separates itself from different coding agents and different runtimes. And one of I think there was a lot of excitement about the idea of intercom or communication between different agents, and I wanted to show you how that looks like in practice with Atomic. And here's how that works. Atomic has built-in subagents. So you can say what subagents do you have, and then you can ask Atomic to build subagents for you as well. But this is just the out-of-the-box experience. So these are all the subagents that it has. It has codebase analyzers for researching the codebase. It has online researchers. It has worker agents, debugger agents, code simplification agents. And then there are a few agents that are specific to this project. These are local subagents. And I think one of the coolest things is you can run a subagent, and you can also have the subagent send a message midstream to the main agent. This is powerful because typically the way that agents are designed is the subagents will run until execution finished and then dump everything to the main agent. But what Atomic can do with its intercom capability is send a message midstream. So especially if you have an async subagent running, it can communicate back to the main agent while it's running. So let's actually do that so you can see how. Spawn an async subagent that asks a question using intercom in the middle of its work to the main chat, and the main chat acknowledges that response. So what this will do is it'll spawn an async subagent and it'll connect to this intercom tool. And what intercom, as I was mentioning, does is allows to do cross-agent communication or cross-session communication. And in this case, there's this subagent that's will get spawned shortly. So it's spawning this custom intercom asker, and it's spawning it asynchronously. So you'll see in the bottom, it's running this async subagent, and it's showing the status of what's running. And you might see in a few moments this thinking status change to maybe like an intercom tool, and that intercom tool will send a response back to the main agent saying that I need some clarity on something. This is incredibly powerful if you have a subagent that's working and then it needs to have it needs to send a notification. And then I'll show you how that looks like for session-to-session communication as well. So let me also spawn another. So it's realizing that it needed to add the intercom tool to the allow list, and it wasn't able to communicate. So here's an example where Atomic can fix itself dynamically. So if there's a problem in a custom tool that it created, it'll notice and then is able to self-correct, which I think that's one of the coolest features, because especially if you're building a complex workflow, workflows are running for multiple hours at a time, and they need to be able to adjust dynamically based off of if there are any deterministic tool call failures. So let's do. Okay, I think it's saying that subagent has intercom unavailable currently. Let me show with. Let me split this tab and show with a session-to-session communication. I'm actually in a pre-release branch, so it's less stable than the production right now. So I'll use that as an example.
So split tab, how did you do that? You just right click?
Yeah, you just right click on the session, and then you click on split right or split down, or there's also a split left one depending on your configuration.
Oh wow!
And then you can also zoom in. So what zoom in will do is it'll expand it fully, and then you can split again. But in this case, I just want 2 tabs. So what I'll do here to show you intercom is I'll spawn another Atomic session, and I'm going to say communicate. So I'm going to tell the other session, load the intercom extension. I'm going to close this. And send a hello world, or I'm going to say, send a hello world message to the other session that you have access to. It should be locally in this project. It's in the demos project. Don't send a message to the other workflows that I have running on this machine, which you could do. So what this will do is it'll use the intercom tool to figure out all of the sessions that are actively running, and then it's able to communicate to the other session by sending a message like hello world. And so it looks like the other, I'm going to say send it to So it should send it to the chat 019. It could be that I have multiple sessions running. Let's see.
You'll find it. It asks for it. I've seen it do where like
Yeah, it should be.
it's like I
I'm
think
actually
this is the one you're talking about, right?
Yeah, I'm gonna do something else. I'm gonna start a new session just to. I'm gonna say load the intercom tool. So this is the session ID. Then this one should also load it. Okay. Yes, message your peer.
Pickling the packages.
There we go. So here, one of the sessions send a message, and the session receives it and can send a message back. So here, like if multiple sessions are named the same thing, it has to disambiguate. So it just sent a message back. This is like an example of peer-to-peer messaging. This is incredibly powerful for workflows because what it allows you to do is have workflow stages communicate in parallel with another, and we'll see how that looks like in when we go into the workflow definition structure. So this is the power of Intercom, and you can spawn as many sessions as you want. So if I wanted to add another session below here, I can spawn Atomic, and then I can spawn another one and split it down here. And I can say, load the intercom module, load the intercom module.
And this is you doing it yourself, but when this is actually going and you're actually doing something in production, this is something that the agents themselves can pick up.
Yeah,
and
exactly.
start doing it themselves.
But I'm showing it manually since I wanna gradually go to that part.
Exactly, yeah.
But in an actual workflow, the agents have access to Intercom. So if you prompt them to communicate with each other, like imagine if you have a reviewer panel and you want to have them going back and forth and trying to convince one another whether implementation is correct or not. That's like a very complex workflow that you can do, and like you can create a network of these agents communicating in the workflow as well with this. But here I wanted to just manually show how that looks like. And so you can have as many of these networks connected to each other, and you can define sub-networks as well in Atomic. So let's say that I want only a specific group of agents to be able to talk to each other. So you can split into what are called intercom groups, and this is unique to Atomic. It can create, if I wanted to pair these two to one another, I could do that. So I'm going to say create a new group for communication, maybe called like test or something.
Wow.
And in workflows, this becomes even more powerful, yeah.
So like, especially for people who are doing research tasks, there's that paper there. Maybe it's for the same paper or the one that's related to it, but there was one where, I think it was at Stanford, where they came up with this research technique where they were just having reviewers, and it actually mattered the order of the people who were reviewing and what the output was, but also the groupings of reviewers and how many reviewers were like asking questions and so forth. So in this way, if you define them, they can start to talk, and then they can sort of procedurally like hand stuff back and forth to each other, right? Like this group over here is QA group 1, this is project management group 2. One could be adversarial, one could not be. And so they also said at the very end, if there was one adversarial person that kind of pushed back, that the results were much higher quality, with all these different language models and so forth. So I always think about that back in my days when, they're like, that one QA engineer would push back saying, well, isn't this going to affect this really random, odd legacy workflow that affects this thing? And the ones who are looking at it, and they're just like, yeah. So that's kind of cool. Like, that's interesting that we have this ability to recreate sort of that. But that's what these language models are kind of modeled after us, right? Like,
definitely.
Like,
yeah.
Wow.
So in this case, it created this group called test, and then it added a peer called test peer. And then you can actually communicate in a scoped group. So you can give certain agents access to groups. This will become more clear why it's powerful in workflows. But I wanted to introduce the idea that you not only can communicate like to a general audience, but you can also scope to a private group of agents communicating with each other.
Wow.
So that other agents don't bias those agents that are. So let's say you could have a situation, for example, where the worker agent tries to tamper with the reviewer and say, actually, I did this right. What are you talking about? But then the reviewers can be isolated so they don't hear that noise. So
Yes.
it's very powerful in that you can do things like that.
Wow. Wow. Yeah, this is blowing my mind. If it's blowing your mind as well, make sure you smash that like and hit that little thumbs up. That really kind of makes it go a long way, because there's just so much that's packed into this second session, and there will be timestamps with this video on demand, and I'm working on editing the first one, but also editing this one as well. So all of this stuff kind of helps propel this out to get it to more people. This is like pretty much breaking news, but like just the breaking way of, working with these coding agents. And this is something that I'm trying to just, bring more to the channel and hang out with my engineering friends here. So we're here in San Francisco live, and this is like, you flew in from Washington?
Yeah.
Just to hang out with us here at the epicenter of like the AI buzz, right? So like there's people all over the world that are doing cool stuff. And then we're bringing it to you live. We also have our friends here in the audience as well. My brother, we got some other folks here, some other half of the Atomic team. We're just kind of hanging out, vibing. Yeah, just do AJ47, aka, yeah. So tech friend who's kind of here vibing with us. And this is the vibes that we're kind of rolling with right now. And hopefully you're also enjoying it as part of a live stream as well. Definitely appreciate everyone who's been able to support, because this is just, this is blowing my mind. And this kind of like masterclass type of thing is also available in the link in the description. We also have something that's currently pinned in the live stream, which is going to give us a crash course. So the crash course for Atomic, I'll put it up here on the screen so y'all can see right now. Let me just kind of
I was selective in this overview that we went over because I wanted to kind of get to our real world demos as well. But this crash course has lower level information as well, like is incredibly specific on what you can do. I was selective here because I wanted to focus on like what are the most important things, and like how can I be hyper specific on the most important things. Otherwise this could go on for maybe 5+ hours, like describing every component of Atomic in absolute technical detail.
Yeah, this is a great, like just going through this can be many hours, but hopefully it's not too overwhelming, but it's very, very comprehensive. And also in the streams coming up in the future with me using this, we'll have some more hands-on. I think it's just going to take a little while to sync stuff in, but it's extremely powerful, and you can kind of start to see some of the advantages of what's going to start taking off here. And it wouldn't surprise me if your favorite labs start seeing this and start incorporating it into their coding agents and their harnesses, because that's just the pattern. But this is all open source. You can take this. And as far as like token burn and stuff, it's not, the promise here is just to make really great software that's composable, letting the agents work in their runtime, in this runtime here. And it's just a very powerful paradigm. And yeah, let's go ahead and start cooking, man.
We're so close to getting to workflows and like the actual power. But I wanted to make sure that everyone had a foundation that they can build off of, because if you didn't understand the first few parts, then the workflows would have been incredibly difficult to digest. There's one last thing with Intercom that it is exciting for me, and that's the handoff that I was kind of alluding to earlier, where instead of using forking context, you can dynamically fork context using Intercom.
Let's go.
And this is one of I think the coolest things about Atomic. So let's say that you were working on a long-running task, and then it went down some rabbit hole, and you wanted to only take a subset of that task, but you want to use the model's intelligence to prune the relevant information, because forking doesn't give you that. Forking is deterministic. It only takes that context and then passes it completely to the next conversation. But here, you can say, I think maybe a good way to do this is I'll just show off resuming. So let's see. So I just resumed this longer session. And let's pretend that this was hours worth of work that you did. And I'm going to tell this one to load Intercom. And then here's a pattern you can apply. Create a handoff message that you would pass to another coding agent in another session and use the intercom tool to send it, the session ID you should be targeting is 85cc2e6. And this is just looking at this session ID because I want to ensure that it actually gets sent here, because I have many sessions running actually in the background. So I'm still improving the system, as you can see, but it's more so challenging how can we scale with existing systems, and how can we make a better runtime layer. So if you're interested that Atomic is open source and is open to contributors, and if you have that same vision of like building community and improving the coding agent runtime space and reliability in production systems, we'd love to have contributors.
Yeah, that's you if you're watching this. Phil asks a really good question here. It's like, how long did it take to make Atomic, and why is this not going crazy? And everyone's talking about Buzz right now. I feel like... Go ahead, yeah.
I'm not sure. Yeah, I think there's a certain type of information that's maybe hype driven. Like the clicks are driven through, oh, this is going to change the world, or like this zero-shotted like a AAA game. And I didn't want Atomic to be flashy at all, really. I just wanted it to be like a practical engineering tool. And I think the way that it was presented compared to other things is maybe like trying to be more practical and like challenging the status quo, rather than saying, oh, we've implemented AGI, or like we have like coding agent AGI, which it's not. And I think that like that thing contributes to, like that perception contributes like something maybe not growing as fast.
Interesting.
And but I think I want to drive the growth of this project and the growth of a community who cares about these things and isn't just driven on hype, and is more like engineering, fundamental engineering principles. And then to answer the second question, how long did it take to build? I think I rewrote Atomic 3 or 4 times from scratch, and each time learned a lot about the harness layer and the runtime layer. And it started as a skill-based kind of system where you would tell the system, I have this specific workflow, and define it. Like maybe you heard of Dex Horthy's research plan implement methodology. Like that was a big inspiration. And like if you're familiar with superpowers, that's another inspiration, and Matt Pocock's skills. And it started kind of as that. How can you build procedures for engineering as skills? And then I started forming an opinion of dynamic workflows and these ideas actually 6+ months before Claude Code shipped these. And then I kind of started thinking about how can we build more reliable systems by reimagining the runtime. And that's where I had multiple iterations. At first I said, can we be constrained to like extending coding agents? Like can I build Atomic on OpenCode or Claude Code or Codex or Copilot CLI? And the answer was no, because it's such a, like, it requires control of the entire runtime stack to where you can't like wrap SDKs around it. Atomic can't be implemented in SDK technically. So I went through iterations of that, ended up like trying to see if I could somehow wrap OpenCode, and then what next went to how I could build a custom UI experience with the SDKs. And then I finally arrived at this approach where I resonated with Pi, and I had used Pi before. I used all of the major coding agents. And the thing that clicked for me is I'm just going to fork Pi and redesign everything from scratch. And then define all these primitives for people to be able to work with. And so this would be the layer that everyone can build with now.
Wow, that's crazy.
So yeah, that was millions of lines of code going through like drafting and ideating over the course of months.
Yeah, blood, sweat,
like
and tears.
6+ months, yeah.
6+ months. Holy smokes. That's crazy, man. Yeah, this is such a great question. We'll get to some more a little bit later. So what you've kicked off earlier was a workflow here?
No, so I just showed a handoff between, let's say that you had a long-running task, and you decided at that point, I wanna fork the task, or like I have a nice follow-up task, but I don't want to pollute this context window. And this is like thinking pre-workflow, but it's an instructive use case where instead of using handoff with /context, which forks the entire context window, the model decides what's important. So it's intelligent enough to go through the context and then and then use the intercom tool to send a handoff message. So notice how there's an inbox message, and then that intercom has sent the message to this current session, and then this current session can take whatever that particular agent was working on and implement that. But I just stopped it because this is to show how that would work. But this is a very powerful pattern, and you can imagine using intercom in all sorts of creative ways. Wow. I just want to show the tip of the iceberg of what's possible. But then the next thing we'll go into is workflows. I think everybody is now looking forward to, we define like this idea of the coding agent runtime, but the thing that's central to it is this idea of recursive state machines, the innovation to RLMs, and this is where we get into workflows. So
cool.
I don't know if you have any comments before that, or
I don't know about you, but I'm ready to get workflow pilled. If you're ready to get workflow pilled right now, this is the time. If your friends haven't joined in, share that share link right now saying, this is game changing. No, like we're not trying to create buzz just for buzz's sake. But like, I think there's gonna be, like, this is probably like one of the more important chapters of like our second session here in this masterclass. He's had to cover a lot of this stuff along the way just so that it can kind of make sense and not really overwhelm you, or you can just be like, this is just too crazy. But just know that you may have to watch this a couple times, and I'll definitely get this clipped out. So I'll let you do your thing. Do you need to use the restroom or take any breaks or anything like that? Or are you ready to go?
Yeah, I'm gonna take a quick bio break.
Okay, cool. Let's hold it. Yeah. So yeah. I'll hold on to the microphone and the magnets. Yeah. It's okay, cool. So yeah, I'm gonna hold it down for a bit. So I'm gonna like show you a little bit of my workflow because this is gonna be really, really important, and that will allow us to kind of get a little bit of break too. So make sure you get some water, get some stretching going, get some munchies as well, because this is gonna be probably a really cool thing. So let me just go ahead and see if I can pull up an existing thing that I have as far as like a project and kind of see what's going on here. Low key, I think I was trying to see if I can maybe go back to what we were working on and see if I can kind of show you some of the stuff I have in progress, because I was going to see if I can maybe see if I could take that P stack thing with the comments and see if I can flip that into something that could be really useful. So let's go ahead and catch up on that workflow that I was trying to build for myself earlier, and then let's see what's kind of going on with that. So over here, I think I had a session that was going over here. So in this case, what I was trying to do is I can probably design my skills files instead of having it as a skill file, but just design it into a workflow. And I was basically just asking the coding agent a little bit more about what that would look like. And so I said, hey, all of my agents and D files should probably just go away and they turn into workflows. And I've just asked the agent to do that for me. So at the very beginning, I just said, here's the P stack from Cursor in this repo, and there's a really good skill in there. And I want to remove the unnecessary comments and all the stuff that's helping me and remove AI slop. I'm wondering if you can review it and help me turn this that skill into a workflow for this repo. Because anytime I want to contribute changes to this repo, it will just kick off the workflow, and I don't have to keep telling it, and it doesn't have to waste its context window, and it'll be able to spawn off multiple things there. So if we have this thing going here, this is kind of what it's been doing. It's kind of been looking through everything, and you can kind of see it. It added these special tags that we talked about earlier. It says keep context. So it says tagging in workflow launches, not deleting the file. So this is its note to itself to keep that in the context as it's going through this entire session. So that was pretty cool. And so which note should the workflow process? So we're gonna have it process all 4 agent MD files. Should the workflow stop for your approval before it builds and gets, it's like, no, fully unattended. Cool. Approve the plan, then run just fully unattended. Let's just YOLO. There's no Claude MD in the repo. What should the workflow do about that? Nothing. And then no comments workflow from earlier design. Yep, but not written. What now? Build this one first and then the other one after. Build both now. Okay. Okay, cool. Submit the answers. Yeah. Let's go. Let's go. Okay. So the user needs all 4 agents MD files with fully unattended execution and no approval gates, which means I'll put in strictness, and let me check the runtime. Yeah, so here it is. So right now it's just using my Opus 5 sub from my Cloud Code subscription. And that's kind of what it's running right now as far as like the, you know, like where is this money coming from and kind of what's being used here. So this is now kicking off. And let me get to some of the questions. Yes, Joao, holy, exactly. Yeah, Atomic was born in October of 2025, and it's been a long and fun journey. Yeah, just getting started. Crazy, right? Did you want to come and talk? No? Okay. Yeah, it's just good. So, yeah, it's really funny when people sign up for YouTube and they hit the little bell. Sometimes it doesn't notify them. So I think I might kick off a separate thing. I think I'm gonna do that right now. I'm just gonna just yap myself into another session. So over here, if I hit new, and I just go to CD project, workspace, dot. Kdir, sp, notify, stream. CD, notify, stream. Oops. Cool, welcome back, man. See Atomic. All right, so help me scope out a project where I want to be able to text my audience whenever I go live. And I want to see if I can somehow incorporate WhatsApp for this, because there's some international audience. And I think there's also possibly a way to do this with Tello. There are other services where you have to pay quite a bit, but I should be able to sign up and get my own number. And I'm based in the US. And when I want people to sign up, I want to be able to use Convex as my database. And then I want them to authenticate using Clerk as my stack. And I don't mind if this is a headless Vite app, or we can even make this an Next.js app actually, because we can have some nice UI for people to onboard themselves and put out their phone number and be able to be notified. And so myself, as a person who's running the live streams, I could just send a notification, and then it would send out a text to everyone letting them know either I'm going live or I am live now. It'd be nice if I can hook up my YouTube channel to it, so when it does go live, it'll just generate the URL that's already live, and then they can just start joining the stream right away. Cool. So here it is. I'm just going to ask the question, and basically just having it sort of create this new project for me. This is a problem that I keep seeing on my YouTube channel, where people are saying, I didn't get notified of your streams. And I thought, well, might as well just kind of yap it into existence while we're waiting.
Yeah.
You know what I mean? So, is there a way to have
interactive.
this do it without this popping up for the search thing?
Oh yeah, you have to, in interactive mode, it automatically opens the browser, but you can, if you go back to the terminal, you can dismiss it automatically, yeah.
I could do /.
So if you, I think, I have to think how to disable interactive mode. I don't.
Maybe I can ask in a different chat.
Yeah, you could.
Let's see. Save.
If that doesn't exist, yeah, feel free to file an issue, and we can have that functionality.
I want web search without. Oh. Without interactive. Okay. Yeah, because I usually have my own. I use like Exa and stuff. Did it auto approve or something?
So actually, Atomic uses Exa by default.
Oh, sweet.
You can configure it using your Exa API key. If you notice, you have Exa. Yeah.
Yeah.
You see how the search was using Exa?
Yeah.
In that diagram.
Oh, /curator off?
Okay, got it.
Oh.
Sometimes I forget about all the features in Atomic, so I will ask it, can you do this for me?
So 3 ways /curator off. That's the curator? No, I still want the curator, right? Raw results only.
Well, I think it's, let me think about this.
We'll return raw results.
I thought the curator was the UI. I'm not sure.
The search curator, human in the loop.
So that was the slash curator, I think. You just turn it off, yeah.
You just turned it off, yeah.
Yeah, so when you did curator off, it shouldn't open the browser now. Yeah.
Is it off for this repo?
No, it disables it globally.
Globally, okay,
Yeah.
I thought so. It just does a check. It's gonna double check your work, sir. This is awesome.
That's a great Uno reverse.
Yeah, it's like we're gonna verify the verifier. Yeah. Okay. Cool. So while it's doing its thing, it's basically scoped out the project. What's your business entity situation? Yes. So it looks like it even gave me some recommendations. So Twilio is 0.0083 per SMS.
Actually, this is a great example because you're showing the create spec skill in effect.
Yeah. I'm basically creating a spec live, sort of kind of yapped part of it into existence. Roughly half of Twilio. Holy smokes! Wait, how is this half of Twilio? 0.004, 0.008. Wow. Also does WhatsApp, slightly rougher developer experience and less community material. I have never heard of Telnix. Wow. Oh, Telnix SMS plus Meta Cloud API Direct. Cheapest at scale, skips Twilio's 5-cent message WhatsApp charge. Most integration work, 2 vendors, you manage the Meta app yourself. Wow. Well, doesn't this one sound like the best? Huh.
I think as the engineer, you have the ability to ask about what design questions make sense. And,
wow. Okay.
And it's this tool is not made for vibe coders. It's how do you create a structured engineering approach? But I think I incentivize people who are less familiar with coding as well to kind of thinking about these approaches and how you design the system, because if you want to build a business and you're non-technical, I think there's a lot of importance in the stack and how you can scale your system, and because it might bite you in the future. So it's always good to kind of, especially if you're starting a project from scratch, to start considering these things and what can be practical as well.
Oh, I see.
I think the difference in pricing is Twilio bundles in the SMS surcharge, whereas Telnix separates it out on their website. And so when you look at the pricing page, it's going to pull that 0.004, but then they say plus carrier pricing fee.
Oh,
which
plus
is the
carrier.
0.004.
Dang. Okay, that's how they get you, because they know agents are searching for this. So yeah, for what he was saying, for those who didn't hear it live, is basically Telnix will not show the surcharge fee that gets added by the carrier, and that basically may come out to the same fee as Twilio. But what I asked my agent here is like, is there any, one of the things that you may ask for is kind of what I'm doing as myself. It's like, it says they may not have a good enough developer experience or may not have as community support. And so what that means to me in my head is like, I want my AI agents to have as much information as they can grab onto. So if Twilio has that and the other agents don't, then it's all it has to do is whatever code base it has, that's all it has. And so it's going to be hard to figure itself out. Usually you can figure it out if there's a code base, but if it's closed source or if it's depending on some server side obscure, toggle or something that is not documented, then you're kind of at the behest of the company to disclose that information, because then your agent's going to run around in circles thinking it's not you, it's me, right? Like type of thing, because their agents are trying to be really helpful. So I think that's also another important thing is like, making sure that they're sort of like agent ready. So this is now the scope here. So Telnix MCP executes the API calls. Twilio's MCP does doc spec search to over 1,000 endpoints, plus the official agent skills package here, plus the MD for agents writing code. Twilio is clearly ahead. The cost delta is $17 a month at 1,000 subscribers, not worth trading away. Scoping on Twilio. Okay, cool. Yeah. So yeah, it's gonna use Twilio. That's awesome. Yeah, it's self-selected. Cool. That's awesome. So yeah, so what we're doing here is that basically I just decided to build a project from scratch right now, while I'm gonna also do a bathroom break as well, but I just thought I was just gonna walk you through what I was doing, and I had an idea of what the architecture of some of the stack that I wanted in my head. and I even the bad spelling of XJS came across like for my transcription, so it was still able to figure that out, which is nice. And so the scope is now written for my document. The design is forced, not chosen. WhatsApp can't send marketing templates to US numbers, so the routing rule is US, SMS, international, and then WhatsApp. There's also a cheaper arrangement. WhatsApp to international audience runs about half of the international SMS, which is the actual business case for your integration. So the long pull is paperwork, not code. Toll free. I think the other thing that I was thinking about here was maybe having an app as well. So I also realized that I could probably ship an app to the App Store. So I know with Apple, I can just send push notifications for free. So why can't I maybe do something very simple like that as well? Copy. Something must have got interrupted. So whisper flow, paste. Cool. And so I'm gonna let this do its thing. And so this is just how I would use Atomic, obviously scoping this out, and it has this little thing here. So once we have like a spec or something we want to land on, is this something where, what would I do next after this to hand off? Like, what would you suggest?
Yeah, I would say the process I'd follow is create an issue on GitHub or whatever issue management system you use, like Linear or Jira. And then I would, once you filed it, I think there's transparency for if you have multiple Atomic sessions running, they can be aware of what each session is running, like treating GitHub as a distributed database for all these tasks. And then there's also, and once you have that, you can prompt Atomic, look at this issue that was assigned to me and implement it in a separate Git worktree. If you want to get extra fancy, you can define a process at which you implement the change. So you can say, I want you to implement the change incrementally in 100-line diffs, create a stack for each, a GitHub stack for each, which will show like how to create that specialized workflow.
Got it.
And then say, after each implementation phase, test that minimal code and have adversarial reviewers determine the correctness of the code, and then move on to the next phase once that gate has passed. And if you split a 10,000 line diff into smaller increments and then having those smaller increments be verified, it produces much better results.
Wow.
Because it's just like a human. You know how a human will look at a large PR and completely get overwhelmed and just say, looks good to me, ship it. But if you give a human a 100-line diff, you notice there's all this specific feedback about something and you get higher quality results.
Wow.
And that's why you see a lot of these code review tools.
Oh.
Like take any code review tool like Greptile or Copilot code review or things like that. And you'll notice that they will they'll restrict the number of files by default. And that's because their engine performs significantly worse with more files.
Interesting.
And so that's their way of avoiding having to review that. Because that's where the performance drops. And Atomic can solve that issue. Like it can make it more, like this type of process more performant.
Let's go. Let's go. Cool. So I'll let you do some of your cooking here. And we'll pop back to my session and kind of continue on and see what's happening with my little app build here. So that'd be kind of fun. So I'll minimize that guy, and then I'll let you get into your sauce here.
If I go back and forth, okay.
Oh, yeah.
Because in my screen, I was seeing like truncation of this.
Oh,
okay, but it seems like it's good on the live stream. Just wanted to make sure I wasn't.
Oh, good idea.
Like,
yeah.
Okay, that's great.
Okay, cool.
That's perfect.
So Atomic is built from Pi?
So Atomic is a fork of Pi, yeah. But it significantly extends functionality. Okay, I think.
Yeah.
Oh, I see where this is happening. So I might need to, is there a way to pin it so that way if I go back and forth?
Is maybe share screen instead of one, hit the little, that guy, and change it to,
actually, I'll just keep this. Okay. If this view is good, right? Yeah. And then I'll go through the guide so I'm not switching back and forth. Okay. So we went through all this process as we're discussing the primitives of Atomic. Now we're actually getting to what is the coolest part of Atomic to me, which is this workflow engine. To walk you through the workflow engine, I'd I want to bring together everything that we just talked about with tools, skills, sub-agents, custom extensions. This is where things start to come together and the fundamentals, and it becomes apparent why I wanted to make sure we understood the fundamentals. Atomic comes with built-in workflows, and if you run /workflow list, you can see all of the workflows that come built in with it. And I'll just briefly describe what each of these workflows do, and then I'll describe how to use a built-in workflow, and then I'll describe how to build your own custom loops and workflows. So one of the workflows that Atomic comes with is called Tournament, and a lot of these are inspired by there was a great blog from Tarek from Anthropic, and he describes different patterns that are used for workflows at Anthropic, and Atomic took some of those ideas and then extended them further to make it like the Verifiable engine. So the Tournament workflow is one of them, where you run several independent tasks, and maybe the best way to show this is actually go through the documentation and walk through markdown diagrams of each of them. So let me go to that. Let me stop sharing and go to the documentation. So if we go to the Atomic documentation and scroll down to running workflows, let's go to there should be a section for diagrams. Perfect. Okay. Let me start with classify and act, because it happens to be one of the first ones here. One of the built-in workflows is classify and act, and it essentially takes a task and then it classifies it based off of what is the particular category of that task, and then routes it to separate stages. And each of these stages will implement that change, and then a decision stage will then determine which of these best implemented it. Where would this be useful? This is really useful when you have an implementation that's open-ended and you're exploring different paths of implementation, and you'd like to see how things turn out if that particular direction that you wanted was explored. And this allows you to quickly go through and run parallel stages and then take the implementation that you're the most happy with. The nice thing with Atomic is it gives you a worktree creation primitive. So each of these stages are implemented in parallel in separate worktrees, so that the stages don't trample on each other and make edits to the same files. So this is a great one for exploration of tasks. The other one that's really cool is the fan out and synthesize one. What this will do is it'll take a task and then split it into worker stages, and then it'll apply a barrier operation. So if you're unfamiliar with what a barrier operation is, it's essentially awaiting all of the stages to finish. And once all the stages finish their parallel or split work, then it's synthesized. This workflow is very similar to Ray's Waves workflow, or the Wave skill that he's been talking about, in that it splits the task, and then you could even have parallel verification happening as well, and then you synthesize those results. But this is the basic pattern. The other pattern is adversarial verification. So you can take a worker stage and you can route it to parallel verifiers, and then this is kind of like, if you combine 2 and 3, you can think of it as being like Ray's Waves workflow, and where you take the worker and then parallel verifiers, each one checks separate things. An example of this could be verifier A checks for code quality, verifier B checks for all test cases passing, and verifier C checks for performance regressions. And then the reducer will be another stage that takes these results and determines, should we keep going or should we stop? And this is one of the most powerful things about Atomic, where you can control the execution mechanism through the runtime layer, and it will keep executing until there's a convergence of these verifiers and reducers. You can read the docs for more information, or the easier thing to do is just ask Atomic about a specific thing, and it will tell you in technical detail about it, or it can even simplify that concept. The other one that comes with Atomic is generate and filter. So this can take multiple generations and then pass an ideation phase, and then it filters out what are the best ideas. So you can think about it like having multiple ideas that are interesting to you, but not all of them will be incredibly useful. So this is like, you can think of it as maybe a distilled version of Adi Osmani's philosophy on taste and judgment, where you can take multiple things that are interesting to you and ideate, and then filter out by the best ideas. And this is where you can incorporate things like human in the loop. And when you select the best ideas, then you can discard certain ideas, and then you can use that to drive a even more powerful workflow. And then there's the tournament one, where you can take multiple attempts at a task, and then you can split it into judge groups. So attempt A goes against attempt B, and then C goes against D. And then you determine a winner from the entire bracket. So it's like you're having stages competing with each other, and the best implementation wins. So this is a very powerful workflow. And then there's a more fundamentally basic one, which is looping until done. I'll give you an example of this one applied to a real-world task. Imagine running CI until everything is green. This is a loop until done sort of task. So until all tests in CI passing, until there's no code generate or AI code reviewer feedback left. And this one is fundamentally powerful, but it tends to work the best when you combine it with these other strategies. And then there's more complex ones that have been battle tested across millions of lines of code, code bases, millions or tens of millions. And these are the goal and Ralph workflows. So the goal and Ralph workflows, and these all, as I was mentioning, these all come built in with Atomic, these 8 different workflows. The goal is like a codex/goal command, but it's much more powerful in that it has a structured approach to this verification task. In Codex goal, what Codex CLI does is essentially has this goal tool, and that goal tool will determine, did you correctly accomplish the task? And the model just determines that in the same context window. And it writes these ledger artifacts. But the thing that makes Atomic much more reliable here is that these stages are deterministic. So there's no reliance on the model determining that you finished. Finishing is something that's concrete, something that's determined by parallel reviewer judges, by all test cases passing, and things that you don't rely on this fuzziness of just calling tools and managing state via the model. And then there's this Ralph workflow idea. You might have heard of the Ralph loop. This takes it to the next level, where you take a prompt for a task you want to complete, or a GitHub issue or a ticket, and you'll first research the code base to identify relevant context for the problem. And along the way to researching the code base, so first the user prompts, I want to achieve this task. Then that prompt gets routed to a prompt engineer model, which optimizes using the prompt engineer skill that I was telling you earlier about in the stream. And then it passes that to a researcher stage, and that researcher stage finds relevant context to that problem being solved. And then the researcher passes to an orchestrator, and that orchestrator implements that feature end to end. And then it passes to 2 parallel adversarial reviewers that check the result. If they're happy with the result, you're done. Otherwise, you'll continue looping in that pattern. So that's another well-tested one. And then the nice thing about the goal and Ralph workflows is that they automatically know to submit comments in the PRs that give you evidence that the task was completed. And this gives you the power of not having to review thousands of line diffs, and having some assurance that via artifacts or reviewing artifacts that the code that you generated has evidence that it's correct. So let me go back to Atomic now that I described these built-in workflows and actually apply them in practice. So So you'll see all of these workflows, as I was mentioning, with the /workflow list command. And there are different ways to invoke workflows. I think the most powerful way is to do it in natural language, where you use /workflow, or is to do it in natural language. But in this case, I'll also show you the deterministic way to spawn workflows, just like how we had a deterministic way to spawn skills. So if you want to run, let's say, let's say I want to run the goal workflow. If I run /workflow and then goal, it shows me an interactive UI. And this is the part where I was talking about Atomic allows you to create custom TUI components for your workflows. And this is just a custom TUI selector for workflow inputs. So I can pass in an objective. It gives a description of what each parameter means. And if you're uncomfortable with just having the model do everything, you can start using workflows this way, where you invoke it via a / command. And then you can, once you've passed all the inputs, then you can run the workflow. But the way that I like to use workflows is I like to give Atomic a task and have it figure out when it needs to use a workflow versus when it doesn't. And the way I'd frame it, because this is a common question I get asked, when do you use a workflow and when do you not use a workflow? I would say it depends on how much assurance you want. If you're shipping something to production, I think it's valuable to spend tens of hours checking that it's correct.
I see.
But if you're maybe vibe shipping something or want to test out an idea, maybe that's where you want a lighter weight workflow, or maybe just use the Atomic harness directly. And so I think there's one of the skills will be determining how much assurance I want in that system and balancing what is this budget that I want. Because I see another axis of test time scaling being the kind of this verification time scaling. Mm-hmm. So running checks until you're satisfied that it's working. So do you want to spend, just like how you want to spend 5 minutes thinking, do you want to spend 5 minutes checking that it's correct? Or do you want to spend 10 hours, 20 hours, days, weeks? How long is your budget?
And that's defined here at either by the / commands, or you can just tell it.
For those, that's where I'd frame it as, I want you to spawn this workflow, and after a certain number of minutes, I want you to stop, or you could say something, or if you have an intuition about something, you can just say, I don't want you to use a workflow for this. That's totally overkill.
Okay. Yeah. Cool. Sweet.
So the workflow list will, as I mentioned, has that capability, and then there's also some nice primitives so you can quickly see what the workflow inputs are. So workflow, if I make the screen bigger, it'll scale it correctly. If I do /workflow inputs and the name of the workflow, it'll tell me the workflow inputs and then what each parameter means. This is just some nice things to have. And then if I want to run a workflow, here's how I'd run it deterministically. I'd use /workflow, and then I'd use something like the parameters separated by the name and then equals, just like how you run a CLI, but this is actually via the chat. And you can also spawn these headlessly, but that might be out of scope just to save some time here. And when you enter here, it will spawn the workflow deterministically. So you see that you got a workflow started message. And I just asked it to map this repo. And the workflow started, and Atomic actually acknowledged that you started the workflow. And then you can connect to this workflow using this /workflow connect command. So this is what Ray was showing for workflow connection. And it shows you a selector with the workflows, and it tells you where the stage is and has an active timer. So right now, one will dynamically update because these graphs are dynamic. So it's almost like an interpreter for the graph runtime. As you're progressing through the stages, it updates. So now you'll see it's 1 out of 5 because it just finished that stage. And here's where we go to the coolest part, where you can visualize the workflow graph and it expanding. So there's an artifact root, which is a deterministic tool call, partitioning the task into separate stages. And I can arrow through, or I can click on items and actually see what the outputs of stages were, and you can steer them in real time as well. So if I want to go to branch 1 in Atomic and actually pause it, I can pause it with escape, and then I can go back and it updates to a pause state. And then I can say continue. And then what happens is you can go and continue the state. Another thing is you can pause. If you pause a workflow and there are dependent nodes on it, the dependent nodes are also paused. And this is like the power of having the runtime, where you can control the execution and resume and pause at any moment. And the other cool thing is you can ask Atomic to monitor that workflow for you. See, can you tell me the status of my actively running workflow? Just give me a quick summary of what's happening. I want to be kept in the loop. And what Atomic has access to is this workflow tool that can monitor the progress, and you can see that it just showed you a widget of what the stages are, how long each one has been running.
Nice.
And then what are the deterministic tools that were called? What were the inputs of the workflow? How do you interrupt the workflow? This is the ID you can use to interrupt it. Or if you're, like me, lazy, you can say interrupt this workflow, or quit this workflow, or pause this workflow. And Atomic will just know what you meant. And right now it's telling me that it's running, and currently running 4 branches in parallel with Opus 5. And each branch is like doing this, and nothing needs you right now. And so you can have Atomic run this workflow autonomously, and sometimes could take multiple hours or multiple days.
Yeah, like in my case, it's run for multiple days because I was just saying, this is a PR and stuff. I did want to get to some questions, and let me know when is a good stopping point so we can answer some questions from the audience and stuff like that.
Yeah, maybe one more thing I would show is quit and resuming workflows and the durability mechanism.
Cool.
Because I think those are kind of go hand in hand.
Yeah.
And then we can pause, and then I'll go over custom workflows, which is where things get even more wild.
Let's go.
Yeah, I'm even leaving out intercom across stage communication because I want to get to the SaaS app demo.
Okay.
Yeah. Okay. So let me quickly show how to quit a workflow. Just tell Atomic, can you quit the workflow for me? And if you wanted to deterministically quit it, you can use workflow quit. If I want to pause the workflow, I can use /workflow pause. So if I do /workflow pause, it'll show me a selector, and I select that workflow. And then it'll pause the particular stage that's currently running. And then I can say workflow resume. And I can resume that workflow. And so in this case, the pausing didn't apply to all of the nodes because some nodes finished before others. And Atomic has this durability or checkpointing feature, which will checkpoint even where you were in the conversation of a stage. And so it's like there's a dual checkpointing mechanism, one for which node you're currently on, and if there are dependencies that are blocked in the graph, and one which will go inside the conversation in the context window of that stage and stop it exactly where in the context you are. And this is beneficial because sometimes an agent is making changes to a file, and those are irreversible changes. And if you're resuming them, you don't want to have to restart that context window because the model's made some changes and that confuses the next resumption. So like you have to think about how do you like treat these systems over time, and that's something that's fundamental. But let me now show you how to quit it. You can also prompt Atomic to quit the workflow, or you can use /workflow quit. And in this case, it sent a message that it quit. And the nice thing is anything that the user does, the model sees. So I ran /workflow quit, and Atomic knows, oh, you quit the workflow. So I'll keep that in mind next time you want to interact with the system. This is like where context engineering and designing the tools the right way comes in. And with that, yeah, we can.
That's pretty funny. That's like amazing, the power that we have here. My favorite comment right now is you can let Atomic go and go work, and basically you can touch grass and something. So yeah, let me see if I can get to some of the comments here because we're a little way behind it, but I want to make sure we get some of the questions answered for you. So the Trader Papa asked earlier, he says, guys, a question, is there a way to use the UI UX laws to create a fantastic UI for a SaaS and just keep everything consistent? I know they're a design system, but it is hard to make models follow the design system and create something that belongs to me so that it just doesn't look like other apps.
That's a great question. And Atomic comes built in, I forgot to mention, with an open Claude design workflow. And that's exactly what it's designed for, following a design system and then implementing it according to your branding. It uses the impeccable skill under the hood as well, where I was talking about you can combine skills and workflows to get great results. And this actually this is a great example of human in the loop. Workflows also have human in the loop. So if you, we'll get into it when I define what a custom workflow is, but you can get a notification that a workflow has requested input. And in the case of the OpenCloud design one, it will ask you for a critique if you have any about the design. And it will also run Playwright CLI automation and things like that, and get you quite good results and matching to the design system. And you can do that with since we're still on the screen, / workflow and then OpenCloud design. And you can or you can say run the OpenCloud design workflow. Or if ASR will work.
Yeah.
Something like that. So that's specifically for design.
Whoa.
Yeah.
That's awesome. Holy smokes, that's awesome. Somebody says, is there a way to hand off when, let's just say you ran out of credits, like on one account, then have another account that you can just start over with? Because some people have multiple of these accounts. They'll have like 2 or 3 subscriptions and just like, hey, I want to hand off to account number 2.
Yeah, that's a great question. Atomic currently doesn't support same account handoff, but it does have fallback model access. And if this is a feature, feel free to create an issue in the Atomic repo. And if you want to contribute that issue, that would be amazing. Like contribute an implementation. But right now they're fallback models.
Just to plug a solution on.
Here, you want to? Here's the mic. Yo, pup, come on down. Cool. Yeah.
Just plugging a solution on that, like fallback, load balancing, multiple account issue. There's something called 9router, and I think there's some forks on it where you put in all your connections, all your API keys. It's open source and gives you one base URL that you could probably connect to Atomic, and it'll have all the models and then smart fallbacks and stuff there.
Whoa, 9router. Let's go. Yeah, get that 9. Get that 9.
Yeah, so you can use a router. And Atomic also has the fallback models field, so you can, if there's an outage or if you run out of credits, you can fall back to the workflow, so you can continue where you left off and have multiple subscriptions. Not same model subscriptions, maybe you can use 9router for that, but if you have different subscriptions like Codex and Cloud Code, they can fall back on each other.
That's incredible. Holy smokes.
And you can do that for the main chat, for workflows, for sub-agents,
Wow. So somebody was also saying, can this work overnight by its own? Yes.
Yeah, that's exactly what it's designed for.
Yeah. So
I would recommend running a lot of your tasks overnight because I think you see the greatest productivity gains because you wake up in the morning and get some code to review. And it's almost like the night is where the work happens, and then the rest of the work is interactive throughout the day that you do, like specking out changes or designing better subsystems and things like that.
Yeah, I think that's what it's turned me into. It's like, okay, I delegated all this work. Okay, this didn't really go like I wanted to. It's not like it burned through a lot of tokens. It was very just, like, okay, maybe I'm just going to trim the fat and just kind of ship this. Because sometimes I'll say, let's just ship the minimal version and create a new GitHub issue so we can track them and create new PRs for the bigger work that needs to be done. Because sometimes that's just what happens in engineering in general. You'll discover there's a bug, but there's actually a greater architecture bug. And sometimes you just need something to ship now so you get unblocked. And then the bigger, more thoughtful solution that needs more testing can happen, in a later timeline. So that's just a really good engineering approach. Do you have a question?
Talk about Santi's case because he's doing the migration and he's doing database migration for 3 billion users.
3 billion user migration? What is this?
But he ran these overnight and finally he texted us and he's like, I went to brunch finally. This is real.
Wait.
Engineers, mental health is
I have your she's
I would say,
okay.
Because people are being forced to work crazy hours now with AI pressure.
Yeah, so
definitely.
talk about that.
One of the great that's a great point. There's all this pressure to implement or deliver tasks much quickly because I view it as there's this productivity misconception. The way that you use these systems, just because they're able to write tens of thousands or hundreds of thousands of lines of code, doesn't mean that that code is worthy of shipping. And this productivity multiplier that people view as 10x as 100x is falsely driving narratives that you should be shipping at that volume, and it's actually increasing the workload and mental strain of engineers and developers overall. And this problem is, so what Atomic is trying to allow you to do is be able to delegate some of that work and have it run autonomously overnight. And so you can kind of, like the funny way of saying it is like, Atomic is helping you touch grass more.
Yeah, because this user has 3 billion users to migrate, or was it?
Yeah, so there was a use case for Atomic where an engineer was migrating for 3 billion users, and that's like a very important migration to get right, and you need as much assurance as you want. And the problem is, the reason that there are so many regressions in the industry right now is because people are getting overworked because of this false expectation that their productivity is 100x, when in reality it's 2 to 3x because of the mechanisms or the tooling that they have around them.
Oh.
And this causes all these like psychological issues with engineers that we found. And
Wow.
we like the tooling and the assurance is important, but it's also like a mindset that we want to shift in the industry. That, and I think Dex Horthy also talked about this, where you should think of productivity as more like 2 or 3x, and then scale the way or like the delegation that you have that way. And in that way, I think you're maintaining a healthier work-life balance and being able to be more productive and ship less bugs. And I think as an industry, we need to do better, like as a whole.
Wow. Yeah, because like it still comes back to the verifier problem. Like who's verifying? How is it being verified?
Yeah.
What's at risk? And so forth. Damn, that's really, really good. I tried installing it via Bun and also npm. When it launched it cannot find the module Pi coding agent. I have this package too. Yeah, I guess it's like Mario. So I think I had a similar issue where there was another Pi coding agent or something like that. How would they resolve that? Or?
Yeah, if you are having issues with Atomic, there are possibilities that since you have a Pi installation, there are conflicting extensions. Atomic already ships sub-agents and Intercom directly. So if you have Pi installed, you might need to uninstall it and then run Atomic. This is just because since Atomic is a fork of Pi, it has the same functionality as Pi, but just significantly extends from the base behavior of Pi.
You can also join Discord and we'll help.
Yeah, if you join the Atomic Discord, we can help more specifically with troubleshooting.
Yeah.
But it involves removing your Pi installation and extensions that are conflicting.
Cool. And I think you're gonna drop the Discord link in the YouTube so that we can, so they can also sign up as well.
Yeah,
Sweet.
as a mixture of experts. Yeah.
Cool. Mixture of experts. Cool. So yeah, let's go into this next thing so we can.
Yeah. So now we have an idea of what the built-in workflows are and what you can do with them. The other important part with the built-in workflows is you can resume them if there's an error state. So this is incredibly important for fault tolerance. That's a big emphasis in Atomic. And the other thing that's exciting about Atomic, as I was mentioning, is the ability to create custom workflows. So one example is let's get creative here. What are good examples of a workflow in this demo?
How about we kick off the project build?
Yeah, we can. Actually, that's a great example.
Yeah, because they'll have a lot of stuff along the way.
Yeah, okay. Yeah, that one will be... Let me show maybe 2 toy ones because there's like human in the loop that we could show. Okay. And that could be potentially interesting to just see how that looks like. So I'll just do some toy ones and then we'll get into that. Yeah, the rest of the primitives are, I think I have an idea of what could be good ones to show. I want you to create a workflow that summarizes pending changes in diffs, and then gates the release decision whether the diff looks correct, And I want you to have a deterministic human-in-the-loop gate, and also classify the risk of shipping this code to production. So here we're prompting in natural language to create a workflow. And the power of this is you don't have to write the underlying workflow SDK language if you don't want. Under the hood, it is a TypeScript SDK. So you could write the TypeScript SDK syntax, but Atomic already has information about what are the best workflow patterns. You still can get better results if you handcraft that workflow, as we've seen with other tools as well. But Atomic provides you a great way to go from 0 to 80% in terms of the quality of a workflow. So it's saying how, and then Atomic asks questions like, what should the workflow treat as pending changes? I'm going to say, let's just do working tree only. When should the human approval gate fire? And let's just do always. What happens once you remove or reject the gate? I'm just going to say write a decision artifact. And with this guidance, Atomic is going to use its workflow engine to create this custom workflow and then reload that workflow so it can become usable. And the cool thing here is that you can create custom UI widgets as well. So the workflows are not necessarily like the ask user question input that you were seeing. They can actually be custom multi-select choice, or actually can be designed very specifically for your taste. And I didn't cover this in detail here, but if you have custom extensions defined in Pi or Atomic, they can be used inside of workflows. So you can put workflows, and then inside of a workflow stage have hooks. And what that allows you to do is deterministically run certain events after tool calls as well. So you can think of a stage as an abstraction for it's like an instance of the harness.
Wow.
But you can also think of an extension as what is like the message by message control. Like you can control what happens after tool call, and you can control what happens like broadly in like the reasoning methodology of the model.
Wow.
So there's very granular levels you can take this.
This is crazy. Yeah, this is like super, I'd say definitely like advanced a little bit.
Yeah.
Like if you really wanted to have a lot of this like control and power, it's really, really cool. So it's actually just writing the workflow file for us in TypeScript.
Yeah, so it's writing the TypeScript SDK format for Atomic. And if you read the docs or ask Atomic, you can learn more about how that works. But essentially, it's a TypeScript. In fact, what I'll do right now is, well, it's actually running the workflow, but I'll ask Atomic while it's running that workflow to show the definition for that workflow. So let's do that. After you run the workflow, actually, while you're running the workflow, can you show me the definition? I want to see how you defined it in TypeScript.
Wow. Oh, so you got to paste it.
I'll try that again, yeah. Can you show me the TypeScript definition for this workflow? It didn't run the workflow yet, so it's telling me how I can run it. Oh, I see. It's probably, this actually makes sense in this case since we define a custom workflow, so we don't want to run it until we've approved it.
It's dilly-dallying. That's awesome.
So here's the definition. This is a TypeScript SDK that Atomic has. And you'll see that you can define custom schemas for strict type checking in workflows. And you can define a risk schema, and this can be structured output for stages. And then you can define a git call. So this is a deterministic tool. And then here's the actual workflow definition. It's exporting a workflow, it's naming it, describing it, what are its inputs, what are its outputs. These are important because since you can nest workflows, it allows you to have multiple layers of kind of these state machines. This is why I call recursive state machines and the innovation on RLMs that I was mentioning earlier.
Whoa.
And then you have this run logic, which will actually go and use the primitives in Atomic like context.tool and actually implement business level logic in the workflow layer. Like context.task will spawn a task, fresh context window, will read these files, will output the schema. The outputs will save to this file, will only output files, and then here's the prompt. Notice how it has the keep context that we had earlier.
That's
because
crazy.
It determined that in the compaction cycle, it would be more optimal if I had this information kept, so it doesn't diverge if I have a multi-hour, multi-day workflow.
Wow. Wow.
And then it has all this other business level logic. I would say if you are a power user, you can eventually start to further refine these workflows and improve them over time. I think workflow design is one of the most interesting problems that hasn't been solved. And it still requires a lot of engineering touch and coming up with what are the requirements of your system.
So you would say that what we're covering right now is definitely a big landscape if you're an engineer with lots of experience. And I would say maybe people who've been coding with AI agents, who've been hitting the wall and smashing their head, they're like, Claude Code isn't it, Codex isn't it. I've tried Pi agents, now I'm like having to craft my own special Pi agents. I've been using OhMyPie. Give Atomic Runtime a shot. It's extremely composable, as you can see. There's a lot of stuff that's already built in that's extending Pi. And you can just kind of start to go crazy from here. And I think it's just, it's interesting because even that person who doesn't have that much agentic engineering experience can still pop in and gain quite a bit of benefits, especially from multi-workflow runs. So as you are learning more about engineering, and maybe you're taking these concepts, like I heard you guys say you should have a reviewer. You're just typing that into the little box saying, hey, can we add a reviewer to a workflow? And then all of a sudden your repo now has this reviewer thing that it's trying to figure out, right? So you could just keep expanding and just keep asking the Atomic agent, and it's going to teach you some more. I want to learn the best engineering practices for using Atomic in my repo. What should I do? Just reverse prompt it, as they say.
Yeah.
But basically just asking the agent back, like, I'm not an engineer. Can you just help me figure this out? And it can it's almost like a consultant. You can just use it to consult.
Yeah, exactly.
Right?
Ask Atomic, what are the recommended patterns for this? Or ask it any questions that you have about these, like agentic engineering. And it has access to that in its knowledge base.
Yeah.
And you can use this as an educational tool as well.
Right.
I think it's very useful in making engineers understand what are the processes and how can you go about getting best results or best practices in production.
Yeah, so I think we're at like 2 hours and 42 minutes.
Yeah.
So what do you think we can cover next that could be useful? Because I think 3 hours tends to be like the limit for a lot of people because it's like tends to be pretty long. But if you're watching, we're going to have timestamps, obviously, like we did in the last one right after this. I'll upload the transcript as fast as possible to YouTube so that way it has it, so you can go ahead and download it. I'll also try to put the transcript on my website, rayfernando.ai, and then that way you can just give it to your coding agents, and then they could just start to still support these live streams. I think I'll let you kind of figure out the rest of the time here, so you can kind of.
Yeah, that sounds good. I think one thing I wanted to show is the human in the loop, and then I could briefly go over this requirements doc and how I'd parse it with Atomic. So that should probably be the rest of the time, and then
cool questions or whatever.
Yeah.
Cool. Awesome.
Yeah, I think that project implementation in itself could be like
one whole stream. Yeah, like 3 hour stream. Yeah. That's a good point. Yeah.
But yeah, let me show you how human in the loop looks like so people can see it actually in action. Can you run this workflow for me? So now it's going to run this custom workflow that it created, and it has human in the loop. And actually expand this window. It has the background task that's running, and has this release gate workflow. And if I connect to it, I can see it working on summarizing the changes. And I can see this deterministic tool call as well. So I can actually follow the progress if I wanted to. Or I could go back to the main chat with Control X and then ask, or even ask it through this main chat or this orchestrator panel. Yeah, so this will run, and it should also spawn a human in the loop after this stage runs. So maybe for the sake of time, because I don't know how long this summarize pending will take, I'm just going to ask Atomic to create a dummy human in the loop workflow so you guys can just see the UI and how that and how that's different. So I'm going to quit this one. Okay. Create a dummy workflow for human in the loop. I just want to see how it looks like.
Somebody had a question about context management in the main chat. Should they have to worry too much about that when they're running the Atomic agent?
They shouldn't, because of the compaction innovations. So if you're, the thing I would like, the neat trick that we mentioned earlier in the stream was the keep context tags. So I would recommend using something like that if there's critical information that you want to keep. And then also using the to-do tool that I talked about, where you can have this file system-based store.
Cool.
Okay, let's see. The human in the loop one. So run this one. Okay, here's how the human in the loop.
Let me minimize mine.
No worries. Here's how the human in the loop looks like. I just ask it to create a human in the loop workflow, and it has these primitives for creating custom UI and inputs. And when it ran it, you'll see that there's one that needs attention now. And there's a question mark next to the workflow that requires input from the user. So if I use Workflow Connect and I go to this question mark one, it says awaiting input, waiting for the user response. If I click on it, I can select the particular, this is like where the custom UI comes in. And then in the next phase, it'll show human in the loop answered, and then I can look at the next input, which is just a blanket input that tries to pick up, or that tries to ask me like a design question. So you can imagine this is very useful if there's ambiguity in implementation. You can actually take that ambiguity and transform it while the workflow is running.
Wow.
So it's a seamless experience.
So this can order my pizza.
It could, yeah.
That's crazy.
You could create a DoorDash CLI workflow.
That's crazy, dude. That's, yeah, like in the middle of it, it's just gonna like, okay, it's like 12 o'clock. You haven't eaten yet, according to your calories and stuff. Pick an option.
Yeah, you could.
This is what's available right now.
And it shows the human in the loop in that.
Bro,
in that
this is... Let's go. This is crazy.
So that probably has a lot of the primitives, but I think we should make the demo on that SaaS app maybe a future session.
Yeah,
because I had
so.
I heard some questions that I wanted to address that I thought would be useful to the community.
Yes.
Because I get a lot of these questions about workflow design.
Perfect.
If that makes sense.
Totally. Yeah.
And the other thing is, there's also an MCP tool in Atomic, but like it has basically everything that Pi has. So.
Wow.
So if you.
Okay, that makes sense.
So just assume that any base coding agent capability is in Atomic already that I haven't covered.
Yeah, because of Pi, because of everything. But then, and then some. Yes.
That's why I skipped over some things like MCP servers, because I implied that exists. Okay, let's get into common questions I see about workflows. One of them is, how do you define whether a workflow is done or not? And that's I think it's like a fundamental question about these long-running tasks. And the way I'd recommend approaching that problem is to create very precise specs. Have a way where you can define that doneness means whether all the test cases are passing, or whether there are no more linter errors, or maybe have like a LM as a review judge that can determine the completion criteria. The model won't always get it right, but you can improve the reliability significantly than if you had just prompted the model to complete a task. because otherwise with that system, you wouldn't have any assurance of what's happening. So that's one thing I hear a lot.
Yeah.
And I think it's also a skill. Like you need to be able to frame problems in a way that they're solvable. Like I think that's an engineering skill.
And you build it over time, just solving problems or seeing
Yes.
them get solved for you.
Yeah. And that goes back to the question that we had, do we still need to know coding, or like do we still need to have that technical acumen? And I think coding allows you to build up that intuition for problem solving.
I see. That's really good.
And the other question I get a lot is when to run a workflow versus not. And to answer that question, I briefly went over it. And the guidance I would give is if the task is complex enough or you require assurance in the system, which I find like all of production code requires that. And but if you're like shipping a one-off project and you want to explore different paths, I would say the answer also depends. Because sometimes you want to explore different paths, and this is exactly what certain built-in workflows in Atomic are great for. You can have parallel implementers of a task, or like explore different directions that are experimental, and then have a synthesizer then determine which of those looks most promising. So in that case, I think it'd be great to use a workflow. But sometimes, Atomic tries to be intelligent at doing this, but like maybe sometimes you just want to rebase a PR and Atomic decides it needs to use a workflow for that. You as the engineer can have control and say, don't use a workflow for that. I think it's a trivial task. Use words like quickly. Quickly implies that you shouldn't use a workflow. I think that framing will change though once we get faster inference and the cost of models continues to decrease.
Wow.
And this commoditization will, I think, allow us to unify these ideas, and eventually you won't have to think about that.
Wow.
And because you're just running the 750 tokens per second
Jesus.
on Cerebrus or something.
Yeah. Wow.
Yeah. And then the next question I get is how to prompt. Like,
okay.
How do you prompt these systems?
Right.
Like, how do you get that right? And this is where the prompt engineer skill in Atomic is incredibly useful. You can have it formulate a vague idea into something that's more organized and then review if that matches your intent. Or even like have a back and forth process. Use the create spec skill in Atomic and have it grill you on, like using Matt Pocock's terminology here, grill you on the implementation and identify what are weak points, or is there something that you haven't been as thorough on. So that's another important thing. And the other thing I would say, other questions I get is, how do you use local models? Because everybody's trying to explore that new frontier, and I think we're finally at a place where we can somewhat reliably. I think it's still not economical like for everyone to do it, because you have to spend like maybe a few thousand on a cluster or tens of thousands depending on what model you want to run. But you can still start exploring with local models in Atomic and maybe take hundreds of million parameter models and using their quantized versions. But I wouldn't expect the type of results you see in like Kimi K3, GLM 5.2, or even DeepSeek V4. And to get good results currently with local models, you probably need like thousands of dollars worth of hardware. I would say though, Atomic significantly improves the performance of these local models because of this principled running coding agent runtime approach. As we've seen, the harness makes a big difference with local models.
Whoa.
Yeah, and for that you can use the built-in Llama CPP integration in Atomic, and maybe that would be like follow-up content since you you have DeepSeek V4 already running on a DGX Spark.
On a DGX Spark. I'm so excited about that. It's so fast, so great.
And I think the final thing I wanted to touch on is what Atomic is designed for, and its philosophy is the coding agent runtime that can be plugged in as a tool that you use as an engineer to build things, or it can be used to power your applications. And it really emphasizes the idea of long-running tasks and complex workflows and things that require high rigor. You can still use the coding agent CLI like you would Claude Code or Codex, but I think you're not tapping into the functionality or the full capabilities of the system if you approach it the same way that you're thinking about using a typical coding agent.
Shines from billions of users.
Yeah.
Billions of lines of code.
Yeah, this thing has a big impact. You know, you can billions of users, billions of lines of code. It's not. This is not a game. Yeah, it's just incredible. So if you're coming in, we're gonna have to do a part 3 for sure.
Yeah, I was hoping we'd get to somewhat of that like initial challenge,
Right.
but I think that deserves a further practical deep dive, because I think introducing people to like what Atomic can do itself was the prerequisite to actually using it on a very complex task. And at least this allows people to have some time to explore and use it on their own code bases.
Right.
And then once they formulated their own way of working with these systems, I think it benefits them since they have this incentive to explore it themselves rather than just listening to someone do it and then like being biased by that workflow.
Yeah, and I think this is a really good one because I've been seeing people try to get these agents to communicate each other from even the early OpenClaw days, where they would put them in a Discord and have the agents kind of talk to each other and build apps and so forth. But what people quickly discovered is that they would burn through their accounts pretty fast. There's a lot of inefficiencies because of just the extra messaging overhead. You know, the agents lose context within themselves. They couldn't understand, you know, what their long context horizon is or their goals. And also organizing workflows in a sense that were very repeatable for certain code bases or certain tasks. And not everything requires these massive mega like conversations and threads.
Yeah.
So I think this is kind of the like the dream realized in like a much more like pragmatic way, I would say, right? Like Atomic being the runtime, being like it controls everything as it's running. It can generate those workflows. It can, you know, manage this context for a very long time, do the compaction, work like, I feel like this is pro level agentic engineering that you can, if you're a pro engineer, you know, you're probably crazy excited about this. You're like, finally, I mean, you've been using Pi, and I think this is kind of like the next like extension of you know, using Pi to be, you know, super crazy with this. I think there's a lot to explore here, and it's just super rich. That it's crazy we've had to do like 2-3 hour streams to cover some of the fundamentals of just this type of thinking. But there's a lot in here because I know people have been trying to learn graph engineering, people are learning workflows, people are learning loops. And I feel like just getting this started will get you pretty far in the conversation to where people are in terms of how they're trying to incorporate these techniques into their own coding agent harnesses, right? So I mean, it's not going to be a surprise if Claude Code picks up a lot of this, if, you know, if actually like Codex picks up a lot of these types of insights and paradigms and things, and they're now going to start marketing them back to you and saying, hey, because I just saw the other day Claude Code released a, you know, Intercom basically. And it's like, I mean, it's been known for a while that you could do this, but you know,
that's existed for a few months now.
Yeah, as far as like that theory. So we're literally here in San Francisco on the cutting edge with our friends here in the actual office. So this is something we're trying to do. We're trying to do some more like meetups IRL, kind of hanging out. And this is just our time to kind of hang out with our friends and just vibe live. And it's like beyond vibing, it's like I've learned so much just in this crazy conversation. I really appreciate you, Alex, coming down from Washington to just
of course,
vibe, to just literally kind of teach us here live and kind of show us some of these things, because I'm going to be building live with Atomic, and you know, I've already spun out. You've seen so many projects that I have in progress, so it's going to be really interesting to do this. And I'm learning little tips and tricks here as this is going. And so the next stream that I do with Alex is probably going to involve like, how do we take something maybe that's a really big project and then just ship it off with this. And then in my own repos, I'm going to show you how I do my workflows, how I just add this into a workflow and let it go. Because as an engineer, I just don't, you know, those verification loops, all of these other things as far as somebody testing and making sure stuff is there along the way. I don't want to be the human that's there all the time reprompting the model. I just want to go to sleep and then it already has taken off and, you know, generated lists of things. So I think that can be very useful there for kind of working on those things. But if y'all have any questions, let us know right now, because this is your chance to do it while we're here live. And you know, I want to give a shout out to everyone who's been on the stream. There's been a lot of different stuff. I've not been able to catch up with everyone's comments, so it's been really, really cool. I know Ruben Garcia was here earlier. I don't know if you're still here, because it's like, what are we doing here? We've been cooking, man. We've been cooking. Also, looks like Trendstar is working on Electron GUI fork. It's been pretty smooth so far. Still not 100% parity yet though. So like I guess he's doing. So there's people doing some crazy projects here as well. So let's see. Is there a way to hand off when let's ran out of credits? Oh, we already answered this one I think earlier about like handing off. So it was called 9router, right?
Yeah.
Yeah, 9router is a thing that you can use if you have like multiple Claude Code accounts, multiple Codex accounts. You can just set the base URL. And huge shout outs to AJ, aka Tech Friend, if you haven't had a chance to follow him, with the sauce, coming in with the sauce, and you can use that so that way your stuff just keeps going. You don't have to sign in and out of accounts because that's kind of a pain in the butt. So it didn't come from us. We have no liability on this. This is you as an engineer exploring your curiosity into the realms of the deep YouTube thing, because who's going to come in here an hour, 2 hours and 59 minutes to come to this exact segment to understand what's going on here. So none of this is any advice that you should be taking. You should always exercise your own caution. These are just two guys here yapping in San Francisco, dreaming big about how to have AI coding agents work for us. And this is just literally our own opinions and our own, explorations live. So we just turn on the camera so you can share as well. And we appreciate you showing up and kind of asking questions here because it's really kind of what makes it go really, really crazy. So yeah, I think big shouts to is it Joao from Brazil. Let's go. Oh my gosh, y'all from everywhere. So let's see. I did something crazy. I migrated from Claude Code to anti-gravity with Google. It's doing better job and faster. So failing faster and improving, especially with Flash 3.6. Okay, that's cool. Let's see. Cool. Awesome. Yeah, let's see if there's any more comments and stuff like that. Yes, 3 billion users. Exactly. Yeah. Also Brazil as well. Let's go. Check it out. The next big thing is, what is this? Just advertising? Okay. How do you run a test TEE to verify execution of a 3P agent? You could just define that in a workflow, right?
You can build any custom workflow you want. Atomic comes with a test-driven development workflow, so you could use that as a base, and you can define your process and use Atomic to construct a custom workflow for that.
Yeah, that's probably like the best way there. Yeah, cool, man. So I think if there's any more questions, stay tuned for part 3. Drop the comments. This is just like, it's crazy. I think it's really funny because this is, like you said earlier, it's not hype driven. This is truly agentic engineering driven approach, and you're not going to hear about it yet on YouTube. I think your favorite YouTubers are probably trying to study this right now and try to figure out how can they explain it to a wider audience, because as you can see, there's a lot of technical depth in here, and sometimes it's just really easy to show some of this stuff in like when you have buzz that's going, it's really easy to show UI and say, click these things, see what happens. And it takes a little while to try to really digest, okay, what's the thread that needs to be pulled out here? And I think the thread that needs to be pulled out from this entire 6-hour course is that agentic runtime is the thing that is just going to be the core foundation here, and how it talks to the language models and how it's managing all these different things are, I think the best way that I've been able to think about this is imagine sending a rocket into space and you have to send your team of robots to do the things. You want to give them all the tools that they need so that they can run autonomously in whatever environment they land on. What if they land on the moon, if they land on lava, if they land somewhere in some black hole portal or something. Do they have what they need to operate to send information back to you and achieve the goal that they need to achieve, whatever you send them out to do, whatever the mission is? So that's kind of the agentic runtime. And I feel when you can, that's agents in the sense or the robots are kind of the people who help you get the stuff done in your code base. And you're going to be giving it these goals and tasks. And I think this is a really important thing. And what it's been able to extend and fork from Pi and then build on top of are that tooling, those primitives that allow these agents to really operate on themselves. And so it could be as simple as just prompting to give them some things, but where you really start to get a bigger advantage is generating workflows that are repeatable, that could be verified following engineering best practices, as you learn your engineering and kind of start leveling up, you'll start to see the value in some of these tools, because just leaving them to the language models themselves to do, they will, as you've seen, they'll just say, okay, I did it, or they'll go about it in a very sloppy way. So what's nice, I feel like, about this is also the opportunity to not burn a lot of tokens. So you're not gonna like be sitting there like, you know, having this thing go in a loop forever just because it's like told to go in a loop for an hour.
Yeah, and the system is still improving and will significantly improve over time. So things like going in this doom loop, like there are mechanisms that are already preventing it, and the technology is becoming stronger as well.
Cool. Awesome. Excellent. So yeah, with that said, I think definitely catch us for part 3 coming up soon. I don't know when. So just drop a comment, thumbs up, share this with a friend, and we'll catch y'all in the next stream. Peace out, y'all. Let's see here.